Welcome everyone to our webinar today. According to market analysis company MRFR, the worldwide smart camera market is expected to hit around $5.9 billion by 2027. As computer vision is becoming smarter due to faster devices, more sophisticated algorithms, and larger networks, smart cameras are employed in an even wider range of applications, such as industrial machine vision and video surveillance. Arm has been at the center of the IoT revolution for decades. In order to facilitate developers and designers to fulfill the potential of IoT, today we are very honored to invite technology experts and Arm ecosystem partners from cloud to device to participate in a webinar to take you through the technical details and the use case of AIoT, especially focusing on smart cameras. The participating companies include AWS, the world's most broadly adopted cloud computing service provider; Himax, a leading provider of semiconductor solutions dedicated to display imaging processing for consumer electronics worldwide; Neuron, a leading provider of edge AI solutions; ADLink, a global leader in edge computing; Tomophone, a leading AI pet tech company; and Pop Security, a subsidiary of eMemory Technology, one of the world's largest stakeholders in logic non-volatile memory technology, which is focusing on PUF-based security IP solutions. In today's webinar, we'll be covering the smart camera market, Arm total solutions of IoT, Arm virtual hardware, the newest ISP that were released recently, popular YOLO V4 model, and Arm AI technology. In the second half of the forum, there will be a panel discussion participated by Himax, ADLink, and Pop Security to share their valuable vision for smart camera industry. For people who are developing AIoT products now, please stay until the end of the webinar to learn valuable insights. Now the forum will begin. First of all, allow me to introduce Mr. Mohamed Awad, VP of IoT and Embedded of Arm. Next, I would like to introduce Mr. Mark Lau, Distinguished Research Fellow and Director at IIS at Academia Sinica. Next, I would like to introduce Mr. Alan Huang, Senior AIoT Solutions Manager of Arm. Next, I would like to introduce Mr. Ricky Chang, Principal FAE of Arm. Next, I would like to introduce Mr. Odin Shen, Principal FAE of Arm. Thank you. Let's welcome Mr. Mohamed Awad, VP of IoT and Embedded of Arm, to give an opening speech.
Hi, thanks for joining us today. I'm Mohamed Awad, VP of the IoT and Embedded Business at Arm. I'm super excited to be here today and kick off the Arm Smart Camera and AIoT Forum. Smart cameras are a key focus for the IoT and embedded business at Arm. Over the next 4 years, we expect to see another billion smart cameras ship, and the majority of them will run machine learning directly on the device. Here with us today, we have some of our amazing Taiwan ecosystem partners like ADLink, Himax, Neuron, Tomophone, Puff Security, and even AWS. It's a great testament to the investments being made in this incredibly important and growing market. As everyone knows, Taiwan has a very dynamic and active technology ecosystem. Arm works with silicon partners, OEMs, ODMs, and partners across the ecosystem to accelerate and simplify innovation. At Arm, we view smart cameras as a key application for IoT because it relies on so many modern technologies. Cameras continue to demand increased compute, machine learning at the edge, as well as vision and image processing. We are also seeing a trend towards smart cameras becoming more software-defined so that OEMs and service providers can easily offer differentiated and unique use case-specific features. These include everything from license plate recognition to things like person or object detection. We are also seeing adoption of smart cameras in verticals as diverse as retail, industrial, and home security markets. And it's companies in Taiwan that are actively making it happen. Arm is deeply involved in providing solutions for this market, which is one of the reasons we launched the Corestone 1000, a platform that is perfect for cloud-native edge smart cameras. More recently, we launched the Mali C55 ISP, which specifically targets the smart camera market. I'd like to thank you again for your participation in the webinar. Please enjoy the talks from ARM and our partners, and please reach out if you'd like to get even more involved. Thank you.
Thank you, Mohamed, for your speech. Up next is Mr. Mark Lau, Distinguished Research Fellow and Director at IIS at Academia Sinica, to give a presentation entitled Industrial Application of Computer Vision in the Age of Artificial Intelligence, using YOLO V4 as an example.
Hi, I'm Mark Liao, the Director of the Institute of Information Science, Academia Sinica. Today, my topic is industrial applications of computer vision in the age of artificial intelligence, using YOLO V4 as an example. My research team was awarded 4-year funding starting from January 2018 to December 2021. The Ministry of Science and Technology strongly urges all teams to implement, let industry raise issues, and let academia solve them. Since the Ministry of Science and Technology strongly endorsed cooperation with industry, we decided to collaborate with the listed integrated circuit company, Yilong Electronics. We hoped to integrate software and hardware to develop smart city traffic flow solutions that are applicable not only to Taiwan, but beyond. The objective of this most sponsored project are as follows. First, we would like to bring academia research development capabilities into industry. Second, we would like to commercialize artificial intelligence technology, let the product enter the international market. And the third, and most importantly, to let the world see Taiwan. The project team has several consensus. First, we select the real-world issues given by the industry and try to solve them in a scientific way. Second, the team members should not only think about publishing papers, try to introduce science into the problem-solving process. Due to this project, we have developed the world-famous object detector, YOLO V4. YOLO V4 was the fastest and the most accurate object detector for 2.5 months. It defeated the teams coming from Google, Facebook, Microsoft, and Qualcomm. As I have mentioned, YOLO V4 was ranked the most accurate object detector in the world. Out of more than 180 teams, including the teams coming from Google, Microsoft, Qualcomm, Amazon, all participated in this object detection competition based on Microsoft COCO dataset. As this slide shows, we ranked number 1, number 2, number 4, and number 6 in this competition. Efficient DAT ranked number 3, and detector ranked number 5, and those ranked between number 7 and number 10 are all Google teams. As for the teams of Microsoft, Qualcomm, Facebook, and Amazon, they all fall behind number 10. In this slide, I will show a demo video prepared by Alexei Bochkovsky, one of the co-authors of YOLO V4. In this slide, it is shown how YOLO V4 can quickly perform object detection. This video was prepared by Alexei Pochikovatsky, one of the co-authors of YOLO V4. 3 papers, articles related to YOLO V4. We released the codes of YOLO V4 and an archive article in April 2020. Up to now, this archive article has been cited more than 4,000 times. As to the CSP.NET, we published it in the workshop of CVPR year 2020. Up to now, it has been cited more than 930 times. The scale version of YOLO V4 was presented in CVPR year 2021. Up to now, it has been cited more than 290 times. Now, I would like to talk about the Smart City Traffic Flow Solutions project sponsored by the Ministry of Science and Technology. The 2 parties involved in this project include the Institute of Information Science, Academia Sinica, and the listed integrated circuits company, Yilong Electronics. The goal of this project are roughly as follows. Yilong Electronics installs 2 different types of camcorders at 5 consecutive intersections on a road in Taoyuan, Dayuan, which is close to airport. One is a 330-degree fisheye camcorder, and this camcorder is responsible for computing the traffic flow within a depth of 80 meters at the intersection. The other type of camcorder is a gun-type camcorder, and each intersection they allocated 4. It mainly calculates the traffic flow from 4 directions. Through the exchange of traffic parameters between intersections, traffic signals can be dynamically controlled. The first year of this project is to use fisheye camcorders to perform traffic flow analysis at intersections. In this kind of environment, the most important problem to be overcome when performing deep learning-based traffic flow analysis is how to perform deep learning in the distorted visual space. The computing tool provided by Yilong Electronics to the R&D team is NVIDIA Jetson TX2. Because the computing power of TX2 is only 5% of that of GTX 1080 Ti, it can only use limited computing power to maintain fast enough calculation speed and accuracy. And this is the biggest challenge we have to face. What this video clip shows is the vehicle detection by our developed systems. Starting in June year 2019, our team began to develop flow detection software for gun-type camcorders. The goal is to develop a lightweight, deep learning-based neural network model that can effectively calculate traffic flow at the edge. The YOLO V4 software is embedded in gun-type camcorder, and one can use it to quickly and effectively detect traffic flow. The YOLO V4 we developed can detect various vehicles and their speed at 430 frames per second. During the night, YOLO V4 can still effectively detect most of the vehicles. As mentioned earlier, fisheye camcorders and the gun-type camcorders can use YOLO V4 to detect traffic parameters at intersections. If the traffic parameters of the connected intersections are transferred to each other, it can be used as a basis for dynamic control of traffic signs. Therefore, we can easily build an intelligent road network system via the assistance of YOLO V4 and the related softwares. And this is a bird view of 5 consecutive intersections in Taoyuan, Dayuan. We dynamically adjust the control of traffic signals by passing traffic parameters between intersections. This table lists the details of each year of our Smart City Traffic Flow Solutions for 4-year project. Judging from the goals of each year, the first step of almost every item requires object detection, and our team has developed the world-famous YOLO V4. In the following, I will detail the process of how YOLO V4 was developed. As mentioned in the previous slide, object detection is a must in many application domains. In what follows, I will show some real-world applications. Our collaboration project with Yilong Electronics mainly focused on traffic flow solutions. Using YOLO V4 as an object detector, the system developed can perform blind zone object detection. This can remind the driver in due course to avoid traffic accident. In the following, I would like to talk about is the inter-institution PM 2.5 research project of Academia Sinica. The members of this project are mainly from the Academia Sinica, and some members are from universities or some medical centers. The number of vehicles and the pedestrians are directly correlated to the concentration of PM 2.5. Using YOLO V4, we can directly estimate traffic volume using online streaming videos. YOLO V4 can be applied to count the number of people within the field of view. This factor also influences directly to the concentration of PM 2.5. In the following, we will report some YOLO V4 related results. The use of oriented YOLO V4 to perform direction and tracking in aerial images. And here are some examples of tracking vehicles, pedestrians from bird view. And here is an example of full range vehicle tracking. Okay, we can use vehicle trajectories to perform traffic analysis. And YOLO V4 can also be applied to perform burying beetle behavior analysis. Via the assistance of the YOLO V4 detector, the analysis time significantly reduced from more than 3 months to only 2 weeks. In today's society, almost everyone has mobile phone. Therefore, it is very important for everyone to have the ability to detect and recognize objects in real time on the edge. Since we are collaborating with Yilong Electronics Corporate, they concern very much about the cost of manufactured chips. Therefore, the object detection model we designed must perform fast and well on the edge. However, the edge side mobile device has a great restriction on the number of layers allowed, so the resources that can be used are also extremely limited, and it is extremely challenging to do it fast and well. Next, I will detail the development process of YOLO V4 and the scale YOLO V4. The 3 authors are from the left to right, Dr. Wang Jianyao, Alexei Pochkoboski, and myself. In conventional object detection, it is very different from deep learning-based object detection. The former has to define handcrafted features and then identify corresponding object in an image. The latter, on the other hand, can be handled in an end-to-end manner. To implement a deep learning-based object detector, we need to train a deep network with a large number of training data. The training will end whenever the deep network is stabilized. During the object detection stage, an unknown image is input into the deep network. Please see the left image. The right image shows the recognized object in bounding box. in the right image, a person is recognized with the probability of 64%. The above-mentioned deep network was developed by Joseph Redmond in year 2016 and is commonly known as YOLO, which is the abbreviation of You Only Look Once. Deep learning-based object detector is mainly divided into two categories. One is one-stage object detector, and the other is two-stage object detector. The main difference between the two is their head. The head of one-stage object detector was dense prediction, while the head of a two-stage object detector uses sparse prediction. Generally speaking, the main body of deep learning-based object detector is divided into three parts, among which the backbone is responsible for feature extraction, the neck is responsible for organization, and the head is responsible for making appropriate prediction. As mentioned in the previous slide, the backbone is usually in charge of feature extraction. Famous existing backbones include VGG16, DarkNet 53, and RexNet 50 variants. The neck is in charge of feature organization. It serves to enhance the feature discriminability and robustness. Some famous existing necks include FPN, PAN, RFB, and so on. Traditional CNN training often relies on backpropagating gradients to train the weight of the network, so that the network slowly stabilized. But the deep network is usually very deep. Therefore, the design of ResNet is to worry about the magnitude of a gradient will be getting smaller and smaller when it is transmitted far away. So a copy is sent to all subsequent layers. However, making copies of all layers will cause a great burden on the network due to repeated calculations, and the speed will be significantly degraded. In order to solve the above redundancy problem, we propose a new network architecture called partial residual network, abbreviated PRN. The design concept of this network is to split the backpropagated gradient flow. This design can reduce redundancy on the one hand, and we propose two versions of partial residual network between June and December year 2018. The partial residual network is shown in this slide, and its variance is shown in the next slide. The design shown in this slide can maintain the same amount of parameters, computations, and the connections. On the other hand, the amount of gradient combinations and the variability can be increased. The design shown in this slide is the variance of the previous one. With this design, we are able to cut down the amount of computations and the parameters while increasing the gradient combinations. We compare the proposed partial residual network with the state-of-the-art object detection algorithms based on speed and the average precision. In terms of speed, PRN can reach 100 frames per second per frame rate, which is 2 times faster than YOLO v3 and 3 times faster than M2DET. As for the average precision, PRN is 4% and 6% less than YOLO v3 and M2DET, respectively. Since the performance of PRN couldn't beat YOLO v3 and M2DET much, we started to design the new network called Cross-Stage Partial Network, abbreviated CSP-NET. The design concept of CSP-NET is still based on gradient flow division. This slide shows a complete architecture of one computational block in CSP-NET. In order to develop a lightweight object detector and that can be used at edge, we propose this cross-stage partial network. The main concept is optimization of the transmission path strategy of gradient flow for the backpropagation process of a CNN. We released the codes of CSP-NET in November 2019. The maintainer of DarkNet, Alexei Bochkovarsky, found this outcome and asked Dr. Wang Jianyao to run the codes on different GPUs, including Maxwell, Pascal, and Volta. The CSP-NET design can enrich combination of gradients, maximize gradient variability, and cut down the amount of computations. If we incorporate the design concept of CSP-NET into the state-of-the-art object detection algorithms, for example, the combination of CSP-NET and the ResNext 50 can reduce floating point operations by 22%. As for the combination of CSP-NET and the DenseNet 201 elastic, the cut down of the floating point operations can be up to 19%. If one only considers the frame rate, bringing in the concept of CSP-NET can significantly improve the AP50 by 20% in the SunderNet case, 9% in the CenterNet case, and 30% in the PZ case. This figure shows the comparison of YOLO v4 with the state-of-the-art algorithm run on Maxwell GPU. Based on the Microsoft Cocoa data set, the horizontal axis in this frame is the frame rate, and the vertical axis indicates average precision in the left and the AP50 at the right. Again, YOLO v4 beats all state-of-the-art object detection algorithm in the Pascal case in terms of speed and accuracy. Here we show the result run on Volta. Still, YOLO v4 beats all state-of-the-art algorithms in terms of speed and accuracy. With very low power consumption of less than 30 watts, very high throughput at 430 frames per second, one is able to perform very precise traffic analysis in real time. Basically, we rewrite the rules of the game through the development of YOLO v4. This video clip is reported by Formosa TV after the press conference held on July 2nd, 2020.
Academia Sinica has teamed up with a Russian developer to build a super-fast, highly accurate object detection system. The system, called YOLO version 4, is already in use in Taoyuan and Hsinchu, where it helps resolve traffic problems. It can also be used to detect whether people are practicing social distancing. Let's take a look.
As soon as humans enter the frame, this object tracking system calculates the distance between them. The boxes are green when people keep at least 6 feet apart. This system can also detect whether the people are wearing masks.
Application can be anywhere, right? Anywhere, including biology and medical treatment and different areas, as long as there's a need of object detection. For example, there's an example about social distance. They use the detector as a first stage and detect the human beings walking within the field of view and try to calculate the distance.
The AI-based real-time object recognition system is called YOLO, which stands for You Only Look Once. The original version was created by Joseph Redman in 2016. The fourth version, the latest one yet, was developed by Alexei Bohovsky and 2 researchers from the Academia Sinica, Wang Jianyao and Mark Liao. It uses artificial intelligence to detect objects, track and judge much faster and more accurately than before.
Usually we say real-time means it's 30 frames per second. Currently, YOLO v4 is able to achieve 430 frames per second. That means 10 times faster than human beings.
One of the biggest applications for the system is traffic image recognition and traffic flow analysis at intersections. The technology has been installed in Taoyuan and Hsinchu.
So this road intersection can detect real-time information and pass this information to each other so that we are able to dynamically control the traffic light. without the intervention of human beings.
Researchers have moved to allay concerns over privacy and security concerns over the new technology.
就把所有的运算都做完。
Because it can complete all the calculations directly on the H end, so the data will not pass through people. You don't have to worry about the privacy of the people at the intersections, or worry that what you do in the car will be seen by others. The data is all handled by the machine on the local side and will not be uploaded to the cloud. It is relatively safe and privacy is protected.
Since the release of the open source code in April, tens of thousands of people worldwide have tested and applied the algorithm.
Okay, my talk ends here, and thanks for listening.
Thank you, Mark. Next, please help me welcome Alan Huang, Senior AIoT Solution Manager of ARM, to give a presentation entitled Smart Camera Market, Industry Analysis and Future Trends.
Hello everyone, I'm Alan Huang. I'm AIoT Solution Manager. Nice to meet you virtually. Allow me to start my presentation about the smart camera market update, including the industry analysis and the future trend. Smart camera is one of the key applications that ARM is paying big efforts and our own investment to support the SIP partner, ODM, OEM, or even the developer to have a better working environment and even developing experience. As the chart in left, you can see the market compound annual growth rate up to 30% from 2020 to 2025. The total available market up to 44 billion, and the SOC revenue will become 5 billion in year 2025. The estimated SOC shipping quantity up to nearly 400 million units in year 2025. All of this coming from three major areas. The first is commercial, and the second is consumer surveillance, and the third is others, just like the dash cam, drones. We also see the trend that embedded vision processor is increasing, as well as the embedded AI solutions. No matter the AI machine learning capability comes from the hardware NPU, GPU, or from the CPU. For the commercial type of surveillance, it's even up to 50% in 2025 will adopt more AI capabilities. Besides the huge market potential we have shown in last page, we found there are three key trends for the smart camera. The first is shift the AI to the edge, which means more AI and machine learning capabilities includes the smart camera SoC instead of compute in the cloud. So the second is more and more demand with a security focus, especially this is related to our personal or even family privacy. The third is cloud native support. So we must to have the capability in our smart camera, then it can be had wider adoption of various and differences, environments, and the scenario support. No matter the camera be used at home or in the factory or even in the wild, to run the cloud native applications had a purpose to reduce go-to-market time and bring in more efficiency. The cloud native umbrella covers many tools and methods, including the microservers, containers, CI/CD, multi-cloud. As you can see, the smart camera are proliferating across industries, including but not exclusive in Industry 4.0, smart city, smart building, and smart home. So all communications and upload through the cloud to content service providers. Talking about the architecture enhancements in commercial smart cameras, we see the transition is more adoption of using cloud service to provide data, video analysis, and modeling training. Also, just store data and running machine learning at the edge instead of previous model of just using local NVR for video storage. So therefore, we can see the big changes. The machine learning capability in the edge is driving camera architecture evolutions. As the picture shows, cloud service provider serve the oriented architecture to the software-defined camera platform. Then it uploaded field data back, and after training procedure, it downloaded the new model back to the camera. The usage scenarios can be the on-demand service deployment application stores or continuous online machine learning model updates. Here is the trend by smart camera SOC hardware configurations. We simply split it as high, mid, and low ends. Simply, the standards will focus on the imaging, video resolution, computing, graphics performance, and the machine learning capabilities. So the current grade will be moved to lower level after 2 to 3 years. But we think the lower end will keep remain in 4K resolution for a while and not actually require any GPU insight. In the other hand, the high end, and we can call it as premium. The premium one will require powerful NPU at up to 20 or even 40 TOPS in the future. So as ARM, we absolutely provide the entire and the completed solution, including the CPU, GPU, NPU, ISP, and the system IP, like the interrupt and the interconnect controller. But we also provide the room in cooperate with third party. For the CPU selection, we recommend at least using A35 or even A55 for entry mainstream level SoCs with Ethos U65 and Mali C55, the image signal processor. For the mid-end, we currently actually most of our clients are using the A55. So you can see from the public announcement, but we are actually looking for the next generation for adoption of A510, the high efficiency ARM v9 CPU, and the Mali G310 and 510 for GPU, and the Mali C55 as ISP. For the high end and the premium one, the current Cortex A78, but we see the future will adapt to the A710. As you know, the A710 is our first generation ARM v9, the big Cortex A core, then with the Mali G710, especially talking about the differences between Mali C55 ISP versus C55 reversion 1. The difference is the R1 is adding the AI capability inside. As many use cases, we see there will be waste lots of time and memory space between ISP and the NPU communications. So to integrate together, which means combine the ISP and the NPU together, will help to improve the performance and the latency, even use less memory and cache buffers. So this chart here shows the demand of security requires items by items, which including first the root of trust, data security, end-to-end security, which equal to edge to cloud, and the data privacy, security boot trust firmware, and the security key management. We also work and contribute the PSA for device certification to fulfill these requirements, and also the process to abstraction for security in a platform. And for the ARM total solution for IoT, the visions, actually we provide end-to-end camera and the vision solutions for various of the market and focus on the security, machine learning, cloud enablement, and the software tools, among with and enabling the vibrant ecosystems. So our customers or even the software developers, actually, they can reduce the time to market, and they just need to using the ARM solutions and just focusing on their value-added differentiations. So this is the purpose we want to achieve. Here shows ARM's solution for the vision platform in edge computing field. We are focusing on the interoperabilities, which means software can be reused and portable across multiple platforms through the standards. We emphasize the importance of security multiple times from my updates, actually. So it's so important then we offer the PSA and the PROSEC as solution. Cloud enabling, so we support the cloud native and the software-defined platform, also involved to complete the solution and the standards. Machine learning, one of our favorites in my deck also. We are keep evolving and aid some evaluations method, including combine the ISP with AI capabilities, and through the cloud service with software-defined camera to training our modeling. The last one, the easy design. We keep working with the third party and the open source with aiding the capability of virtual hardware platform. My colleague, Ricky, will addressing this later. So here shows the value chain of smart cameras from the IP and the ISP providers to the silicon partner, OEM, ODMs, to the service providers. ARM are actually all deeply involved and working together with this entire industry. And deeply thank you all the presenters from AWS, AD-Link, HiMax, Naren, Thomas Fang, and the PUF Security to join and co-present the section as well as the panel discussion. Thank you for all of your listening and looking forward to hear you soon. Thank you.
Thank you, Alan. Next, please help me welcome Ricky, Principal FAE of ARM, to give a presentation entitled Accelerating Your IoT Products Development with ARM Solutions.
Hello, everyone. I'm Ricky Zhang from ARM Taiwan. I'm ARM FAE in charge of IoT and security segments. I was an application engineer in Renesas from 2007, and the main task to establish CPU platform and development boards. In 2011, I worked in TI as a CPU FAE for IoT market and development, and moved one of my focus in motor drive segment. In 2014, I joined CMSIS as a CPU FAE for proprietary CPU IP, then moved to ARM in 2018 until now. For 15 years of my working experience, I spent most of time in IoT and embedded market. And now it's my pleasure to share with you a journey ARM pictured to accelerate IoT development flow. Let me show you first total solution for IoT. The breadth of potential of IoT is extraordinary, addressing applications throughput, our daily life. IoT market demand varies from time to time, but silicon offering is not able to catch up the path of the change. It is clear the existing development flow is out of date. We need a modern design approach and focus on faster time to market, optimize development for, and reduce in risk with the proven solution. Total Solution for IoT is an industrial first, bringing together specialized processing capabilities with standardized, secure software and innovative approaches to tooling and development. Start with a reminder of what we launched in October last year, a new solution-based approach to IoT design, including 3 pillars. Total Solution for IoT, Virtual Hardware, and Project Centauri. Stay tuned, I will walk you through each one later. The ecosystem has embraced this design approach and the new tools and platforms we have provided. It is truly simplifying and modernizing the software development, accelerating time to market for developers, OEMs, and service providers, and reducing product design cycles by up to 2 years. Since then, has been working closely with partners across the ecosystem to get these solutions in the hands of developers and to discover what more they want and need to succeed. We believe that Total Solutions will accelerate product design cycles by as much as 2 years. It all starts with Coston. Our Coston subsystems are pre-designed, pre-integrated, and pre-verified hardware subsystems. They target specific use cases, and we deliver them directly to silicon partners. Next, we have Virtual Hardware, a virtual representation of the Coston subsystem. We are making them available in the cloud at the same time as underlying IP and Coston design. We are doing this so that modern software development can bring right away, long before silicon is available. It can increase the developer velocity for the OEM that is get their developers to produce products faster into the market while integrating the larger variety of required new technology into the products such as machine learning and security. Project Centauri on the right is an ecosystem initiative and delivers software leverage and scale with defined standards, security frameworks, and abstraction from RTOS complexity. Altogether, Total Solution from IoT collapse a typical IoT product development time frame from 5 years to 3 years. Let's jump in each other in some more detail later. Next, let's take a look at the roadmap. Here is a look at the roadmap. The first total solution for IoT is available last year. It is targeted at machine learning use case like keyword recognition and use the Cortex-M55 with Cortex Ethos U55 based on Coston 300. At April this year, we launched 2 platforms for cloud-native edge application and vision application. As this roadmap shows, is committed to this solution-led offering, and M is for our full portfolio to include total solution over time. This is how we are bringing IoT technologies to market moving forward. So we will see some core names for future IP and subsystem, but I'm not going to talk about those days today. But I would like to give you a grasp of next generation vision platform for smart camera right after A53 and M55 platform. Now, we have also an Cortex-M class total solution based on Corstone 310. And our first Cortex-A total solution based on Corstone 1000. Our first total solution for IoT was focused on keyword spotting. And now we are adding to the portfolio with a solution focused on local voice recognition, lightweight vision application. So partners also let us know they want to be able to use the same solution-based approach in higher performance application, which we have enabled by incorporating the Corstone 1000 subsystem in our third total solution. You will now have a full solution at the higher end of the spectrum. We have worked hard to strike a crucial balance here, providing all the essential ingredients for a complete solution, but maintaining enough freedom and flexibility to allow developers to create. Corstone 310 offers SOC designers a reference design that acts as the foundation of secure, high-performance chips based on the brand new Cortex-M55 CPU, which we are also launching today. It has been specifically built from the ground up to leverage advanced capabilities of the CPU, helping designers push MCU performance and security to new heights. It also includes support for an optional ESU55 MPU for added machine learning acceleration. With the Corstone 310, it is easier than ever for our silicon partners to quickly build the highest performance, most secure MCU available, targeting use cases like smart speakers, drones, and smart thermostats. Let's take a closer look at that new Cortex-M50 and 85. Microcontroller software developers are facing extraordinary challenges as the IoT evolves and they look to add more and more functionality and intelligence to their products. The developers either need to find ways to squeeze more processing per clock cycle out of their current microprocessor, or they need to drop some feature. Neither is ideal. Both are time-consuming. Beyond that, security is always a looming threat. The Cortex-M microcontroller family already offers many benefits like determinism, short interrupt latencies, advanced low power management modes, and integrated hardware enforced security through trust zone. But the M55, M85 takes a step further. It is the ideal choice for an application that have additional performance and security requirements. It starts off by adding enhanced microarchitecture features for increased scalar performance. And then it adds the power of ARM's Helium technology to enable support for machine learning use cases. It also can service the demanding DSP use case, such as high fidelity audio processing without a need of DSP. And of course, key to any IoT and embedded system is security against malicious and unintentional exposure of confidential data, which is why the Cortex-M85 supports trust zone, but also is the first Cortex-M to integrate the point authentication and branch target identification extension, so-called PAC-BTI from the new ARM v8.1M architecture. This significantly simplifies and accelerates the developer's journey to achieving PSA certified level 2 security. If we compare the performance of M85 against M7 and M55, it's different in different performance domain, like in traditional performance and mixed performance domain and machine learning performance only. We can see that M85 gives much higher performance in scalar as well as machine learning workload by enhanced microarchitecture. Let's switch now to Coston 1000. The IoT market is about more than MCU. Applications like smart camera, POS, robotics, and industrial automation require more performant platforms that can run a rich operating system like Linux. ARM Total Solution for IoT addresses that space with the Coston 1000. The best configuration for the Coston 1000 leverages Cortex-A32, but it is designed to scale all the way up to a Cortex-A53 in order to support a wide set of performance points. The design also includes a Cortex-M0 Plus to create a heterogeneous system, which is performed extremely power efficient and has been designed for security from the ground up. To ensure operating systems like Linux just work and to ease software development, the Coston 1000 has already achieved system-ready IR compliance. In addition, the Cortex-M0 Plus processor with separate OS and system resource act as a secure enclave in which to store secrets and process sensitivity data. This means that the Coston 1000 is immediately ready for PSA Level 2 certification. This is a great example of how we are accelerating time to market for the entire ecosystem. But the design is system-ready, IR compliant, and immediately ready for PSA Level 2 certification. The Coston 1000 is Project Cassini ready out of box too. Silicon partners get to market faster. Software developers can easily land their code on the platform, and OEMs can quickly achieve security certification. It's why Coston is at the heart of our total solution for IoT offering. It's why we have had such a great reception in the market, and it's why we continue to invest in them. Take a closer look at the next generation vision platform that we plan to target. This is a platform based on cloud-native edge platform with supplementary hardware blocks for vision application, such as latest ISP, which we will talk in detail in next slide, and machine learning island, an expansion block for neural network processing acceleration. Altogether, complete a reference design for vision application, which brings better user experience to our partners. This is what we target next for smart camera partners. This new solution builds on more than 15 years of experience and success in the image field. It was first used in camera, then naturally extended to smartphone, and more recently to IP camera, with a total of more than 2 billion products shipped today. by our partners embedded ARM ISP technology. Over the years, ARM has also pioneered multiple leading-edge image technology to enhance the image quality. ARM also announced 18 months ago the Mali C71 ISP designed and tailored specifically for automotive applications, and it supports functional safety. And in 2019, we are unveiling the Mali C52 and Mali C32 for intelligent vision devices in embedded and IoT. Launched earlier this month, the ARM Mali C55, ARM's smallest and most power efficiency ISP today, is highly configurable and support a high dynamic range HDR feature. Next, we will talk about ARM Virtual Hardware short for AVH. 8 months ago, we also launched AVH, a cloud-based offering which delivers a virtual model of the cold storm subsystem to enable software development without the need for physical silicon. This approach has allowed our ecosystem to easily adopt modern cloud-based development and CI/CD without the need for large custom hardware farms. With ARM Virtual Hardware, product design cycle can be accelerated by up to 2 years. Safe to say, it has been an absolute game changer, and today, we have had hundreds of developers using ARM Virtual Hardware, with positive feedback coming in from the likes of partners them. It's been a real success, but as exciting as this is, we have been getting consistent feedback that we should extend our ARM Virtual Hardware further. Developers want to be able to evaluate workloads on different processors and scale testing into the cloud for current MCU-based design. They also want to scale evaluation, training, and testing without the need for hardware, and be able to seamlessly transfer development from an AVH model to a physical board. In a market this diverse, streamlined development is absolutely crucial, and we have to focus on the core customer, the developer. Over the past 8 months, we have invested and involved our total solution for IoT with the critical new elements I just walked about to deliver these developers the choice, flexibility, and simplicity they need. We established 3 core tenets we need to live by in order to give the IoT and embedded market what it needs. The first, scale. We must enable scale. This means make it so that developers can focus on innovation, not on porting software from device to device. Second, acceleration. We must streamline the development flow process. This is all about accelerating time to market and simplifying how products are developed. And finally, leverage. We will need to leverage the ecosystem. We can't do it alone. We will need to work with partners to reach millions of developers and OEMs. The 3 pillars of ARM total solution you see on the slide are designed with this core principle in mind. And as you have heard today, We are continuing to invest in all three of these areas with more custom designs, incorporating brand new IP such as Cortex-M85, a broader AVH library that gives developers what they need, and a stronger framework from which to drive adoption of standards across the ecosystem and new software components to speed up innovation. At the intersection of hardware and software, ARM is uniquely placed to lead the ecosystem in doing this. We are extremely excited to have had so much engagement from our ecosystem since we first launched this radical approach to IoT design. And today marks a huge milestone in further enhanced in tools, technologies, and platforms our ecosystem needs to continue to innovate and scale IoT. First, we are announcing models for additional Cortex-M processors as part of the ARM virtual hardware offering on AWS. We have added 7 of our most popular Cortex-M models. On the tooling side, we are actively making it much easier for other tools providers to support ARM. GitHub, the most popular source code hosting service for developers, has asked to integrate ARM tools, including compiler and a virtual hardware into their service. It will mean users can get AVH where they already go, saving them from any complicated setup process. We are also integrating ARM virtual hardware into Kyle tooling, making it a neutral part of the development process. Kyle MTK Professional now also includes the Cortex-M ARM virtual hardware with the capability to run them locally and to accommodate traditional embedded development workflows as well. And finally, we are bringing ARM virtual hardware support for existing third-party ecosystem devices, as well as Cortex-A53 in line with the new total solution for Cortex-A. The first devices to be added include popular development boards from Infineon, NSP, ST, Micron, as well as a virtual Raspberry Pi. By extending ARM virtual hardware to ecosystem devices independently, independent software vendors and cloud service providers can now take advantage of the billions of ARM-based IoT and embedded devices which are already deployed. Looking at this slide makes me really proud of what ARM has achieved in the past 8 months. What we now have is a vast library to draw from and to build a total solution for IoT. More custom with new IP, we have gone from offering from 1 to implementation of AVH to more than 10. And we are making huge progress on standards with Centauri, Project Centauri, including now offering all of these new software stacks for use cases such as keyword recognition, voice recognition, and Linux-based use case. Last piece, Project Cassini and Centauri. The IoT world does not stop at the edge to create compute intelligence. From cloud to edge, gateway, and all the way to endpoint devices. The challenges are fragmentation and scalability. Next, We will walk you through Project Cassini and Project Centauri to show you how ARM addressed the problem. Project Cassini is an industry initiative to ensure cloud-native experience across a diverse and secure edge ecosystem. It is made up of three main components: robust standards leveraging software, but also allows for celebrating hardware diversity. Second, security API and certification that can be trusted by developers across workloads and ecosystems. Third, cloud-native software stack and reference use cases. It is aimed to enable the ecosystem to leverage the significant investment being made in the cloud-native software and enable ease and accelerate intelligent edge and IoT deployment. Breadth, the size of ecosystem partner pool guarantees a high quality and competitive offering. This is a list of system-ready partners from OSV, ISP to OEM partners. ARM's solution is based on three parts. First, ARM Virtual Reference Platform, reference software stack, and cloud-native reference use case. Let's first look at the ARM reference platform. This is specified by a compliance program, ARM System Ready, provides a formal set of compute platform definitions to cover a range of systems from the cloud to IoT and edge to a standardized ARM-based hardware. Reference software stack, giving confidence that operating system and subsequent layers that would just work seamlessly across a very vibrant, diverse ecosystem of ARM-based hardware. Last one is cloud-native reference use case. Software can be developed on the cloud. Here is an example that machine learning object detection and classification can be contained and developed in the cloud. When the design ready, it can be deployed on any ARM system-ready certified reference platform for software portability. Now, let me show you a demo.
We'll start the demo by introducing the different components that make up the demo. Here we have three ARM-based hardware platforms, which are connected to a host machine, and we'll be communicating with these platforms through the host machine here. And we also have a stack of three web cameras. They're USB cameras which are connected to the hardware platform, and they are pointed at a video which is running in loop. The idea is to feed the video into the live video into these hardware platforms so that they can do the processing of these videos as frames on the device. The three hardware platforms here are completely different from each other. They use different SoCs and are built by different SoC vendors. So here we've got the IMX8M Plus, which then we've got the Raspberry Pi 4B. Here we've got the Rockchip RK3399 Pro D platform. The only similarity between these platforms is the fact that they're running exactly the same Linux image, and the fact that they are all system ready IR compliant. We'll now move over to the host machine. And here on the left, we've got the Raspberry Pi. In the middle, we've got the IMX8. And the last one is the Rockchip RK3399 platform. Along with showcasing a single Linux image running on multiple system-ready platforms, we also want to showcase how we can run a single unmodified cloud-native use case implementation across these same multiple devices. In the interest of time, I already have the inference containers running on the IMX8 and the Rockchip platforms. And what I'm going to do now is run the pre-processing containers that will then talk to the edge, to the inference container that is already running on the device. On the Raspberry Pi, also, I will only instantiate the pre-processing container, which will then communicate with the inference container that is running on the cloud. And we'll be showcasing, and there we can see the video feed being captured from the screen here and being processed in the captured through the Raspberry Pi and being sent to the container running on a cloud instance for inferencing and being displayed back on the traffic monitoring UI. We will now switch tabs so that the inferencing on the other edge devices may also start, and we should see the images appear shortly. The delay on the edge device is slightly longer because the performance is much lower and the model is currently not optimized to run on edge devices. As you can see, the video is now playing on all three devices.
Project Centauri delivers platform standards and reference implementation for specific applications, boot, security, and cloud connectivity. Foundational standards that are developed in the open and define common interface required by CSP access on device. Standard API delivered by Project Centauri include the PSA Security API and Open CMSIS CDI. A standard cloud-to-device specification that enables device to work with different cloud solutions with minimal engineering effort. And for cloud service provider to scale across all ARM Cortex-M based devices that use CDI. Project Centauri also delivers a set of software components and reference implementation. Software components are delivered through the IoT stack, IoT SDK, and includes embed TLS, TFM, and also MCU boot service. It is a reference implementation, and a reference implementation of OpenCMS CDI will also be available, enabling developers to deploy CDI quickly across a wide range of ARM Cortex-M based devices. Finally, I would like to thank for you attending and working through ARM Total Solution for IoT with me. If you have any question, feel free to contact me or ARM local office at any time. Thank you.
Thank you, Ricky. Next, please help me welcome Odin Shen. Principal FAE of ARM, to give a presentation entitled How ARM AI Technology is Enabling Intelligent Devices with Neural Network Model.
Hi, thanks for joining us. It's Odin, Principal Engineer from ARM Taiwan. Look at the machine learning technology solutions. As the previous speaker mentioned today, camera is such an interesting area, which is people is keen to developing more intelligence on the edge device. Today, I will go over the smart camera and being to redefine the AI and machine learning workload. Then introduce how to use the cloud-native concept to implement end-to-end development flow. Hope you can enjoy today's talk, and feel free to let me know if you have any questions. Here's today my agenda. I will start over the smart camera machine learning trend, followed by the neural network running on the loads of device. Then share such an exciting how I leverage the virtual platform to do the machine learning platform. Here's several of the machine learning use cases cover the wide range of the segment for your reference. I believe that you already saw a lot of industry already. They are the billion of devices today are running the machine learning on ARM. And the people, they desire to apply the more and more machine learning use case into their device. Today, the many of the camera systems rely on the human vision, detect, recognize, and track the object. Thanks for the machine learning revolution. In the past few years, machine learning has been the key technology on making the camera more smarter. Key machine learning algorithms enable the impact to the object detect, image segmentation, tracking, and create a boundary. Future systems are increasing the security and the intelligence with the emerging algorithm, like the human pose estimation, or enable the voice interface on the camera. While those are many of the vision, voice, and the vibration use case in the smart camera, today, my presentation will cover the object detection, segmentation, and the human pose estimation. Analyze the many of those use cases range from the 10G apps to the 10T apps, which are developing the high performance on the Cortex-A based systems or the low-powered Cortex-M based systems. Depends on your target market, where you are designed for the low power or high performance. In the power and area efficiency market, common machine learning process trend will be lower the negative the camera resolution, lower the machine learning processing resolution, lower the complexity of the pipeline, and focus on the single task. Also, the lower the complexity of the individual network on the given task. Talking another way, key definition in the high-performance camera, or maybe the NVR, network video recorder, will likely have the 1, high resolution, either the negative or machine learning processing interface input. Second, the high inference rate, 30 to 16 inference per second. The third one, the process the multiple machine learning tasks per frame in order to achieve the loss of a product goal. Now, let's dig out a bit into the specific machine learning tasks running on the loads of platform. Shown on the left, this is the traditional camera. 2 people, they walk down the step. On the right, show the 3 overlapped object detection for the localization and the drawing the boundary bars around the person. Also, segmentation for identify the security boundary and the post-optimization. There are many of implementation for those of key algorithms in the smart camera area. Let's talk about each of the in depth. First, let's talk about the object detection. Object detection is one of the primary use cases for the machine learning in smart camera. Being able to localize the object in the frame, maybe drawing the bounding bars around it, enable the more of the tracking and the motion to predict the future location. As an arm, we analyzed a lot of the machine learning workload. Look at the machine learning model for the object detection and the localization. You can see that this is a bunch of a different machine learning model. But the question is, what is the factor we should consider when selecting the neural network for object detection? First thing, we need to decide how many clusters to do need to detection. Do you need to detect just people or just car? Also, what kind of accuracy? Second one, what is the resolution you will need to process in the full negative camera? The third one, what does the performance level look like? Do you need machine learning to do every frame at the 6 frames per second, or something like just 5 or 10 frames per second should be satisfied? Lots of a different neural network model for the object detection, like the YOLO and the SSD, which the Professor Lai mentioned before. And recently, we also see a lot of EssentialNet have come out with a range of different kinds of algorithms, from the D0 to the D7. We list in the table. Depends on the use case and the camera, you can select the low power camera. The use case could be use the Essential DNet D2. There's only the 11 GOPS network the operation rate. Or the high performance, use the camera with the efficient DNet D5, more than the 100 GOPS for the one of inference. Here's just an example for your reference. Now, let's talk about the segmentation. Image segmentation is another task in the camera, which allows the user to easier to create the boundary condition. Like the photo should show, your house, you can you identify where is your house, the area. Again, let's check what is the factor we should consider when selecting the neural network model for segmentation. First thing, we need to think about what the scenario you are trying to segment. Is that just a road or a sidewalk, or is it just a person? It depends on different scenario. There could be very different computing requirement. Also, what the accuracy is acceptable for this product? Is a ADAS product or is a home camera? They could be quite different. And again, what the resolution is needed. It depends on the camera input. They could be very different resolution requests. For mainstream camera, you may select the Deep Lab V3 Plus and the MobileNet V2. That's around 6 GOPS network. Let's use the running the 60 frames per second as an assumption. So the total machine learning operation should be around the 350 GOPS per second. Now, let's talk about more interesting part, the human pose estimations. Human pose estimation is developing a machine learning task which can help save the life in the real world chaotic scenario. For example, we can use the technology to send in the medical team to stop the traffic if the person facing some accidents in the street. So what factor we should consider when we select the neural network for human pose estimation? First thing is a very trivial one. How many people do you need to expect to detect? And the second one, how many key points you need to each person? For example, do you need to detect all the finger or just a few points for the body? and what kind of a resolution is required for capture to detect the key point. Are you already used the object detection network and the full input resolution to detect person? And what kind of accuracy target accept for the product? A high-performance AI camera must select 24G apps network like an efficient post, which is the input in the input 480 by 480 resolution. Again, let's use the typical 6 frame second inference second per second request. It could be 1.4 T ups, the computing requirement. Now, we have a quick understanding about the loss of the smart camera related model. The next topic I will show how can we squeeze the more the model. By leveraging the ARM, there's a lot of open source model has already tuned and to perform better on the ARM hardware platform. Use object detection, SSD mobile net as an example. ARM already improved the 30% performance lift. And talking about another ASR model, like the Wave2 later, which is optimized more than the 10 times fast performance in the resource-constrained embedded device. All of the ARM model has already available in the open space and open for all of the community to use. Please check a link to find more detail. So we talk about the loss of a different machine learning use case and how complex about the model. Now, let's discuss how can ARM support loss of machine learning computing requirement. In 2021, we have announced the Cortex M55 along with ESUS U55 for the endpoint AI segment. For higher machine learning computing requirement, like a smart camera, industrial is looking for the more higher than machine learning performance and the running on the rich operation system. That's the reason we developed the ESUS U65, which is the next generation of the ESUS U family. You can use the ESUS U65 inside the Cortex M system or also integrate with the Cortex A as well. Compared with the previous ESUS U55, U65 improved the MAC capability and the memory bandwidth. In this table, you can see the ESUS U65 provide the double of the MAC capability and due to 128-bit ASI master interface for more of a memory-hungry machine learning use case. Let's talk about their benchmark. Here's the benchmark between the ESUS U55 and the ESUS U65. You can see that ESUS U65 provides 2.5 average machine learning performance in many of the typical machine learning model. We described 3 of the major machine learning for the camera application. And we introduced the latest AI processor. Now, let's talk about the development tool. Many of the developers are asking me how can they access the hardware in advance. Based on the ARM base model technology, we integrate both the ESUS M55, Cortex M55 and the ESUS U65 and the 55 processor into the virtual platform environment. That means developer can use the function equivalent simulator instead of the real hardware. By AWS cloud computing infrastructure, those of the virtual hardware already in the AWS marketplace now. Please visit the link for the AWS detail. Here is the end-to-end workload for the endpoint AI developing in the future. Developer will start from the machine learning model training, optimization, and use the neural network optimizer after quantization phase. The neural network optimizer identified the graph to run the ESSU and did optimization, scaling, and memory allocation. After that, developer can configure and build the system and compile it with the related software library. I know a lot of people love the idea, which they can develop in the application without the real hardware in the hand. Now, I'm so excited to announce the model called for the additional Cortex-M processor as a part of the virtual hardware offering on AWS. We are adding in the 7 of the popular Cortex-M processor from the Cortex-N as well as the Cortex-A55 on AWS. You can also bring the virtual hardware support for the existing third-party ecosystem device. The first device will be added into the popular development board from the NSP, STMicron, and also the virtual Raspberry Pi. By extending the virtual hardware to the ecosystem device, the software provider and the cloud service provider can take the advantage to reach out the building of the ARM-based IoT device and the embedded device. Let me give you a short demo about how it works. Let me summarize today's talk. We are building the AI solution on the ARM, and we are looking for the use case first. With the ARM, the domain-specific expertise, we can help you to design the solution from the vision, voice, and the vibration AI algorithm running on the ARM platform. We believe AI is a generation change in the computing that changes everything from the cloud service to the tiny IoT device. ARM will continue to provide the AI solution for smart camera and help our partner to reach out the coming big wave. Here's the link. You can access the link to log in. Once you got logged in, you can click the Create Device button to find out which one the device you want to create. Like I mentioned, the Raspberry Pi, IDAMX, or STMicron. In my system, I already launched the Raspberry Pi here. You can see here, once click, the familiar screen, you can see that. That is the Raspberry Pi running on the server. I can use any kind of Linux command to access the device. Furthermore, you can also use the SSH to use the terminal to access tab. In this case, I will write a very simple Python application to do the sorting. Here it shows the existing time is very quick. The algorithm is running some sorting from the 0 to the 1999. They were rendering the 10,000th the number, integer number for the sorting. Then I can also use the bigger number here. They will take the more longer times, and I can use the more bigger number to run it again. Here's an example. You can trade the virtual hardware as a real device in your hand to do everything you want. Thanks for your watching. Thank you.
Thank you, Odin. Now we will start the hands-on section. Run on virtual hardware and SOCA in secure and reliable IDE on AWS.
We have talked about how the virtual hardware can help the machine learning developer. Now, we are very honored to invite AWS solution architect Zheng Wei. He will give you the introduction about how to use the SOCA to build out the security and the reliable virtual environment for the machine learning development. Hi, Zheng Wei.
Thanks, Odin. So in my session, I will introduce how to use the virtual hardware offering combined with the AWS resources, especially AWS official solution SOCA, to build up the development environment on AWS. So we can bring some cloud benefit for you to efficiently to finish your product development on the cloud. Thank you.
Yeah, that would be very exciting.
Hi, everyone. My name is Zheng Wei. I'm AWS Solutions Architect, focusing on the semicon and the EDA workload on AWS. So today, I'm happy to share the topic about how to run on virtual hardware and the AWS official solution SOCA to build up the secure and reliable IDE environment on AWS. So we know that a lot of challenge when customer want to do the product development to fulfill market requirements. So building the product, especially for hardware, is complex, and the development often exceeds several months or even a year from the concept to the production. So the hardware development are always looking for the guidance on the design consideration and the development trade-off to decrease the hardware design time and also increase the value of the connect devices can bring. So every choice of the hardware developer can make the impact, the cost, and also the time to market of the product development. So consideration might include some local and also cloud connectivity, protocol, security, and also software ecosystem. So sometimes hardware developer must choose a combination of the hardware and the software to address this consideration while optimizing for cost, decreasing the time to market, and also ultimately decrease the risk for the product development. So our goal and also the customer challenge is always to reduce the risk, increase the time to market, and also cost during the hardware development. So we are happy to see that collaborate with the AWS to launch the virtual hardware offering on the cloud. So it delivers the module of the based processors, system, and the third-party hardware in the cloud for the simulating memory and the peripherals, removing the complexity of the building and the configuration all from the testing. So it also integrates some modern product developer technology, including the DevOps and also MLOps workflow. So this new cloud-based offering can really benefit the customer, especially for the hardware, physical hardware development, and reduce your design cycle. So combined, when customer can use the virtual hardware on AWS, this brings some extra benefit to you. The most important thing is to transform from the worrying about from the CapEx, capacity, and also technology to focusing on the innovation. So we expect to see some outcomes that we can bring the benefit to our customer, including the innovation faster. So by using the AWS and on virtual hardware, you can use the flexible configuration and virtually unlimited scalabilities to grow and shrink your development environment based on your needs. So whatever you have one key development project or several small projects that you need to leverage the cloud resource for development, you can always control and manage your cloud resources by your needs. So that's easier for you to predict the IT cost and also management your overall project cost to finish your final goal. The second benefit is about the manufacturing smarter. So what I just mentioned about is the virtual hardware also deliver some turnkey solutions to integrate the modern agile software development practice, such as the DevOps and the MLOps workflow. So that's easier for you to build up the hybrid cloud environment and integrate your existing workflow to AWS. The third one is about the cooperation on the cloud. So you can easily use the cloud offering to build up the secure and reliable IDE environment on AWS and release that environment to R&D team, and so they can connect to virtual highway environment for secure product development. So security is always a job zero. So the AWS mission is to transparently discussion with the customer, understand your needs about your development environment, and we can, based on your requirement, to build up such kind of environment on AWS. So here is an example about how user interaction with the product development process. So there's some code requirement for this environment to provide advanced development simulation and modeling capability for each independent group, providing the self-service with minimized dependencies on other teams. So imagine that you have a lot of product team that they are working on their own projects at the same time. So how to avoid some resource competition and release their productivity is a key for infrastructure things. So by using the AWS, you can always build up the multiple CI/CD pipeline and release each of them to your development team. So development team can use this development environment under the control. So you can set up some security policy, resource limit, and the quota. So on the team, don't need to worry about any communication efforts with the IT infrastructure team. They just use this purpose-built environment and start using the CI/CD pipeline to kick off their project. So they don't need to waste time to and waiting the resource preparation. Always is just one click and some automation solutions that we can provide from AWS side. So when we integrate the DevOps approach for the product development process, absolutely it's an Amazon best practice. What we are doing every day to develop Amazon devices, we are following the same methodologies. So we are always asking about the cost of performance, but when we consider that in addition to that, we are always considered to how to provide the convenient environment for customer so they can do anything what they want. So some criteria, critical requirements about the self-services, resource optimization, agility to involve R&D environment as needs change, and also how to provide a capability so customer can optimize AWS infrastructure based on the budget automatically, maybe to scale and scale in by using the different AWS pricing model, including the spot, on-demand, and the reserve instant. And also, this infrastructure can have a capability to provide a monthly report. So R&D team can always transparently to understand the IT cost day by day. So they don't need to worry about how much cost they will spend for the product development. And also finally, its ability to optimize the job automatically. And some other considerations you might need to think about is AWS expertise, and also how to integrate this technology with the engineer team, and also speed of the implementation, and also you need to understand the AWS cost to operate. So our final goal is always to simplify the engineer's experience to enable the self-services to unlimited resource in a sensible way. So every R&D, every engineer with pre-grant privilege, and also it has a manageable resource quota. Every engineer always can feel free to log into the cloud development environment to start their jobs day by day. So whatever they want to launch the video session to log into this environment, and they need to stop the build job when they finish the code. And also they want to retrieve the outcome from the storage to get the report, and also maybe kick off another round for the build job when they find any bugs which need to be fixed. So everything, if that can be automatically, so that can really bring the big benefit to R&D team. They don't need to waste extra time to communicate with the IT infrastructure team to prepare that resources. So this actually reflects to our new working model we are proposing to our end customer, especially during the COVID-19 situation. So imagine that when you work from home or you have a less chance to talk your manager or IT manager to prepare your resource for your product development. You can always get a self-service portal to get any IT resources for your project. So we are thinking that that may be quite a new normal. It's a new working model, perfect fit during the COVID-19 situation. Okay, so based on this, from AWS side, we are proposing a new digital engineering solutions called SOCA. It stands for the Scaled Computing on AWS. So you can get this detailed information on our landing page. And also we publish the source code on the GitHub repository. And then you can feel free to download that source code to start the SOCA deployment in your AWS account. What's the SOCA solution? Actually, it's the production environment. It's a framework behind the ML devices team that Dev 126 use for everyday HPC jobs. So your AWS Amazon consumer devices like Kindle and Echo devices, they are all made based on this SOCA environment. Why we are offering this solution? Our purpose is trying to enable engineers and scientists with the minimal cloud and the cloud Linux experience. You don't need to worry about too much infrastructure thing, how to install OS, how to deploy the CI/CD pipeline to fit your product development. What you need from IT part, we can deploy that and offer you as a turnkey solution automatically. That's why we provide the SOCA solutions for you. So combined with the virtual hardware together with the SOCA, we can build up the reference architecture like this for you for an IDE environment. So by using the CDK and the CloudFormation template, you can deploy this IDE environment in very short time to get the UI UX interface. So graph interface can allow the R&D team to log into this SOCA portal by using the security connectivity, either direct connect or VPN connection. We offer you an elastic load balancer, so multiple users can use the unified URL to log into this SOCA interface. And behind that, our users can free to launch the virtual hardware environment based on different hardware spec. How many CPU, how many memory or disk you like to get to launch this virtual hardware. It's just the form for the R&D users to select. So backend system will launch this virtual hardware environment accordingly. And in the backend storage system, we are offering the several options, including the ML EFS and also FSX for Lustre, integrate with the ML F3 for the large amount of the storage system for you, for the input and also both for the output. When you finish the job, you can always keep your data on the ML F3 as a data lake. Then you can free to download the output from the cloud to the on-prem environment to review your code. And finally, when you verify that it's workable, then you can deploy on your hardware development. So now I'm going to show you a demo about how to use the SOCA together with virtual hardware to build up the development environment for your designer. So the first of all, you go to visit the AWS Marketplace and search the virtual hardware to find the product page. Then you should be able to see that publish the virtual hardware here in the AWS Marketplace. Click this link and go to the product page. Then you can start review the product information and also get some information about the pricing structure, and also check how many regions you can start to deploy the virtual hardware machine image for your designer. Then you need to subscribe this product from the AWS Marketplace. So click this button to continue to subscribe if you want to use that. Then our backend system will validate and approve for your request, so you can start to use the virtual hardware in your AWS account. Here in my account, I subscribe this product in this day, so I can start use the virtual hardware for my demo purpose. The next step is to deploy the SOCA environment. So go to instance, which is the SOCA CDK installer. I already download the SOCA install package in this environment, and go to the installer folder and execute the SOCA installer.script to start the CDK environment for the SOCA deployment. Then I give some necessary parameters for SOCA CDK. Then it will convert your configuration into the CloudFormation template and start to deploy your SOCA environment. So for those configuration that you need to give for SOCA CDK, you can check our SOCA document to get more detailed information. Okay. Okay, so I already gave all necessary information for SOCA CDK. Then click enter. The SOCA CDK will start to deploy your SOCA environment in your AWS account. Then you have to wait about 40 minutes to 1 hour for the deployment process. Then after that, you can start to access your SOCA environment from your account. So next, when you finish the SOCA deployment and go to the CloudFormation console, then you can get the output information about the SOCA URL. Then enter that SOCA URL in your web browser, so you can start to access your SOCA environment and give the default account and also password to log into this environment. Okay, so now I can log into SOCA. And the next step is to register on virtual hardware machine image in the SOCA environment, so the designer can select that software stack to deploy the environment for their build
job. So here, give the Army ID of the virtual hardware, and also select the Ubuntu 20 for the operating system. Give the proper number for the disk space, and also give the name for the label of this Army. Then you can click this button to register Army in the SOCA system. So after the registration, and go to the Linux desktop. So you can start to deploy the virtual hardware here in the SOCA environment. So first thing, give the name for your session alias, and also give the number for your storage size. Then here in the list, you can select the virtual hardware that you just registered in your SOCA system, and also define the proper configuration for your instance size to tell the SOCA how many CPU, memory, and maybe you need a GPU instance to run your virtual hardware environment. So after you give those configuration, you can click this button to launch your VDI session. So maybe wait another 15 to 20 minutes, then SOCA VDI will be ready for your use. Then when the virtual hardware environment is ready, the SOCA will prompt you this button. So you can just click this button to redirect to the virtual hardware environment by another new tab in your browser. So here I can log into my virtual hardware environment. Okay, so when I click the activities and start a terminal, then I can switch my account to Ubuntu. Okay, so here you can see I can log into the virtual hardware environment successfully. So for today's demo, I already download a demo project from the website. And also I finished the compile for this demo project, so I can directly run this executable to show you the result. So here you can see I can successfully run this demo project and simulate the microphone to detect the signal to check if I can hear the words right or not. So here is the demo to show you how to use the SOCA environment with the virtual hardware together to build up the development environment for your designer quickly.
Okay, so that's a simple example to show you how to launch the virtual hardware with the SOCA environment to start the standalone environment to finish your project. And we also have some follow-ups to show you how we can cooperate with the ARM to provide you some advanced scenario, and also especially integrate your CI/CD pipeline for your engineer to develop the project more agile. So here is a reference architecture about how to run virtual hardware with SOCA, and also has a DevOps platform capability integrate. So here is an example flow. In the SOCA environment, you can also build up the private GitLab repository for your code management. So your code base can commit to the private GitHub lab. When your engineer want to start the build, they can push the code to the VDI section. And after the review, engineer can feel free to start the build code flow. And the GitHub server can integrate with the runner and to trigger the CI/CD pipeline. So the backend system will launch the multiple build servers for you, and the engineer can start their building jobs on the SOCA environment. So every build the jobs, there's another functions called the Lambda to monitor your runner status. And after the job is finished, the outcome can be stored into the backend shared storage system, and also export to the MLF3 as a data lake. So you are always free to keep your data securely and reliable on the MLF3, and it also offers a very cost-effective storage offering for you. And also, we have some transfer family services with variable transfer protocols for you. So you can build up the private and secure security channels from the AWS side to your on-prem side. So you can start your secure data transfer from the cloud to the on-prem. When you finish the review, you can deploy your code without any problem. We know that ARM already offer the several training codes for you, so you can systematically to learn about how to run the ARM virtual hardware by different scenarios. From AWS side, we also provide you an official SOCA training course for you. So if you are interested in using the SOCA, how to get that and deploy the SOCA environment on AWS for the secure ID environment, you can start from this thing. So we are offering this training course for free. There are about 6 modules for you, so you can learn about the SOCA concept, and you have a chance to do the hands-on workshop for you, so you can practice how to deploy the SOCA in your AWS account. So we encourage you that if you are interested in how to use SOCA, please feel free to subscribe this training course with your AWS account. Okay, the last page, I'm closing this session. So we are glad to co-work with the ARM to offer the virtual hardware and combine the AWS official solutions on AWS for you. The purpose is to reduce the risk and improve the efficiency to help you to develop your product faster, for you increase your time to market, and also do some cost optimization during your hardware development. By using the AWS, it's always flexible for you to offer your various cloud resources. So you can always, based on your project need, to scale and scale in your cloud infrastructure without any extra cost. So it's transparent, secure, and reliable AWS cloud resources for you for using the ARM offering for your product development. So any more information you are interested in about the ARM virtual hardware, please go to visit the ARM website to get more information. Okay, so I'm closing my session. Thanks for watching this video. Any problem and any support you need, feel free to contact the ARM and the AWS team so we can offer you more support for you. Thank you.
Thank you, Odin and Wei, for the demonstration of ARM virtual hardware. Next, please help me welcome Naren to give a presentation entitled Next Generation ARM-enabled AI Chips Accelerate Smart Cameras Everywhere.
Hi, this is Charlene Jin representing Naren's CEO office. It's a pleasure to be here today introducing our work with ARM in enabling next generation AI chips to accelerate smart camera devices. For starters, however, let me give some introduction to Naren's business and technology. We are a full stack edge AI company enabled by a proprietary configurable NPU at the core. On top of that, we tape out our own ARM CPU-enabled AI SoCs based on which we create compatible AI models, provide tool chains, build half-turnkey module solutions for some of the more common use cases in each vertical. So in short, we are the single port of call for all AI needs that device makers may want to integrate. Next off, here's a little summary of our management team, our core management team. Our co-founder and our founder and CEO, Albert, he holds a PhD in electrical engineering from UCLA. Prior to establishing Naren in 2015, he has held both R&D and management positions at Qualcomm and Samsung. Our co-founder, Professor Frank Chang, is WinTech Chair and Distinguished Professor at the EE Department of UCLA. Formerly, he was also the president of National Jiao Tong University in Hsinchu. So a little bit of where we are at right now. Since our founding in 2015, Naren has developed our unique reconfigurable NPU, which is now combined with high-performing in-house ISPs for edge AI applications. Our products mainly include AI chipsets, algorithms, and AI software platforms for extended applications. As far as applications go, where the focus right now is on automotives, followed by edge servers, security, and AIoT. When I speak of IoT, I'm talking about smart home devices, smart city, smart building management, etc. Over the past couple of years, we've also gained quite a bit of recognition for our work. When Gartner came out with their first Edge AI report last year, they featured us as one of the key providers. And we have also received from the IEEE CAS Society the Darlington Award, which is definitely the highest honor in electrical engineering. Or more specifically so, the paper regarding our reconfigurable NPU architecture received the award. Definitely one of the highest honors. To date, we have raised 125 million USD from global VCs. We have 210 employees, more than 20 PhDs among us, and 70% of us are in R&D. Our investors include Horizons Ventures, Qualcomm, Alibaba Entrepreneurs Fund, CDIB, Sequoia also on board. Strategics include Foxconn, Lite-On, Delta, Linbon, Himax, MXIC, etc. All right, so a little bit of look at the edge AI chip market. So we are seeing definitely a trend moving from the cloud towards the edge for pretty straightforward reasons. Number one, you reduce latency by processing everything on the edge. And secondly, of course, you have better data privacy and closes a lot of loopholes for hackers to get in through the cloud connectivity. And last of all, of course, bandwidth is money when you have to send data back and forth that consumes cost. This said, our TAM, including IoT, security, auto, we estimate that to become 20 billion by the year 2025 with a CAGR of 49%. And our vision is to be the leading edge AI chip provider. And as you can see, we already, with just our first 3 chips, cover the full range of edge all the way from AIoT to edge servers. In the meantime, we also observe that the older incumbents' strengths exist mainly in the cloud. So the edge really is the main frontier of contention for underserved use cases. Alongside our hardware, we offer complete AI SoC solutions. We offer tools including NPU tools with leading compression technology, ISP tuning tools enabling high image fidelity, fisheye dewarping, end-to-end AI image and audio applications. We also offer integrated edge NPU plus ISP plus encoder solutions that are capable of serving various AI models and compute power requirements with cost and power efficiency on both fronts. We support various sensors, including time of flight, structured light, RGB, NIR, radar, and LiDAR. We also support all the major AI frameworks and models. Okay, so a little bit more about our technology, especially on reconfigurability. So at this point, we're capable of supporting 4-bit MAC blocks, 4-bit MAC arrays, which we can use to form 8x4 MACs, 4x8, or 8-bit MACs. So we have very highly flexible architecture that allows reconfiguration to run on different AI models based on customer needs. And in terms of efficiency, definitely heads and shoulders above many incumbents in terms of frames per second per TOPS, which is, at the end of the day, the actual performance relative to computing power that matters to end users. And in terms of flexibility, as I mentioned, we support all the major AI models, including both vision and voice-based, and now also the transformer. definitely going to be a big deal for the future of AI. And here's another little look at how we compare to other folks. So here's actually a chart extracted by a paper from Professor Kurt Kurtzer, definitely a luminary at UC Berkeley and formerly CTO of CMSIS. So he lined up in this paper what he thought were some of the more effective AI edge AI chips out there. So you can see based on power throughput comparison, everybody's along the same slope. So similar performance efficiency. However, our KL720, which is being compared here, it's taping out at 28 nanometers, whereas other folks are taping out mostly at 712 nanometers. As you can see, a lot of these are for auto use cases. And so this means that given even the older processing node and a lower cost, we're capable of reaching the same performance efficiency as other solutions. And as we go forth towards next generation AI chips, we will move towards lower processing nodes. And this side, we also anticipate to have even better performance compared to others at the same processing node. So in terms of our product roadmap, thus far we've had 100% tape out success rate, and we've been able to commercialize starting from the very first chip that we taped out, which is the KL520, the order of millions of shipments. Going forth, our hardware solutions will continue to expand across different compute power levels. The KL630 for mid-level compute power needs has just recently taped out and is now on the market. And of course, our solutions are powered by ARM CPU, starting out with the M4. We will continue to move towards the A5, A35, and A55, as well as future upgraded solutions as well. And here's a little overview of, as I said, our latest KL630. It is a fully integrated AI chip with NPU, ISP, and video codec. So a little bit more about how we synergize with ARM. ARM Cortex-A series is a world-leading processor, of course. Beyond just bringing PPA benefits, it takes a step further in changing the value of security mitigation in memory, robust secure framework support for PSA, and machine learning performance supported by DSP extension support. It is aimed at enabling easier to maintain security implementation and prevention of memory safety vulnerabilities. So now let's take a little closer look at what the features provide. First off, Secure EL2, which provides a standard secure isolation for trusted services and enables an easier way to maintain security in devices. The memory tagging extension is also a key technology for the detection and prevention of memory safety vulnerabilities. One more important aspect is the control flow integrity addressed by mainly two features: pointer authentication and branch target identifiers. These two hardware mechanisms enable strong prevention of return-oriented programming and jump-oriented programming attacks. ARM also extended the crypto support by adding instructions in Neon and SVE2 space to accelerate cryptography algorithms relevant for rich embedded markets. So altogether, these features aim to provide a better user experience with a secure environment from both a hardware and software perspective in response to rising demand in connected devices. So a bit more on the ARM Neon technology. It is an advanced single instruction multiple data SIMD architecture extension. The Neon technology is intended to improve the multimedia user experience by accelerating audio and video encoding and decoding, user interface, 2D and 3D graphics, and gaming. Neon can also accelerate signal processing algorithms and functions to speed up applications such as audio and video processing, voice and facial recognition, computer vision, and deep learning. So just now we've spoken a lot about hardware and going to talk a little bit about our other offerings as well. In software, we offer 3D face recognition, people detection, virtual fencing, object detection, etc. And one of our main key strengths really is in 3D face recognition, liveness detection with more than 99.99% accuracy. And if we turn that into the door lock, we can run that. We can run such a module, including an RGB camera and face recognition, AI model hardware, plus LED screens. Some of our customers choose so. We can run all of that on 6 AAA batteries for more than 6 months, assuming 20 uses per day. Doesn't have to be plugged into anything. And I think that's definitely quite a feat. Also, a little bit of bragging here. Definitely, we have a very experienced team of engineers coming out of top engineering departments and with decades of experience working at major incumbents prior to joining Naren on the team. So a little bit more about our latest technological advancements. Last year, we taped out the KL530, which is the first AI chip to be commercialized, supporting 4-bit data processing with the same level of accuracy as 8-bit and 32-bit data processing. We can represent data of just 4 bits with almost no loss in precision. At the same time, the data throughput efficiency increases by 8 times and 2 times respectively compared to 8 and 32 bits. Plus, the amount of time needed to process data becomes 1/2 compared to chips supporting 8-bit or 32-bit processing. This is done by implementing instruction sets that compress the data. Part of the instruction set is done on the software layer. Part of it is done on the hardware layer. This means that the KL530 can support higher frames per second with lower hardware specs and lower power consumption. On top of that, it can simultaneously detect more objects at any given time due to its higher computing speed. Next off, the KL530 is also the first AI chip, edge AI chip to commercialize with the ability to support transformers, which is in itself a whole new class of artificial neural networks, artificial intelligence neural networks. Using hybrid transformer and CNN processing, we're able to increase the accuracy of inference results due to the transformer's unique characteristics. The CNN beats existing language processing models as well as the transformer beats existing language processing models as well as most image-based models due to its 2 key features, temporal and spectral image processing. So let's start with temporal image processing. Transformers have an added time dimension considering when they do inferencing. CNN are good for processing single frames, such as face recognition, but not that good for processing continuous frames, such as in behavior detection. So whereas CNNs can tell the difference between a cat and a dog just fine, when it comes to a hug, 2 people with locked arms versus a fight, also 2 people with locked arms, it could look like the exact same thing to a CNN. On the other hand, a transformer will be able to tell between the difference of a hug and a fight, because aside from considering spatial dimensions, it also considers the time dimension. So anything aside, any data that involves time series, for instance, language processing, behavior detection, is better done with transformers. Transformer accuracy is 30% higher than CNN continuous frames. Thus, they're good for taking discrete frames of road image data and making better sense of them as continuous event. On top of the temporal element, I also want to talk about the spectral aspect of transformers. Transformers make inferences holistically, whereas CNNs make inferences based on key features such as eyes, ears, mouths to determine the identity of an object. So, say for instance, wearing a mask could challenge the CNN's ability to recognize a person. On the other hand, the transformer assesses all features holistically. In the auto use case, for instance, the accuracy afforded by this holistic inferencing could be life-saving. Say for example, if a car approaches a horizontally crossing truck that has the image of that is white colored on a cloudy day, then the car using CNN would in fact infer that the truck is an object that is above the horizon. However, a car enabled by transformers will be able to holistically make an inference based on all nearby features and infer that the truck is a truck. So now onto our ISP. Our ISP supports both 360-degree and 180-degree fisheye lens distortion correction, faster hardware dewarping, and up to 6 channels of video inputs, as well as stitching and blending. So just for some demonstration, here's a view of our fisheye corrected scene reconstruction from a ceiling-mounted camera. And here's the exact same thing, but for a wall-mount camera. Our video enhancement capability can remove blurred light from images, so taking out quote-unquote ghosts. And our AI algorithm, on the other hand, can identify and track the sources of different simultaneously occurring voices. It can identify and remove background noise. So next up, here's a preview of some of our current as well as next generation applications. So as far as indoor camera applications go, these include payment-grade liveness face detection, motion detection, behavior recognition using invisible light for healthcare and smart home settings, panoramic images, segmentation and re-ID, as well as AOI and facility safety applications. Our outdoor camera applications include pet detection, crowd detection, virtual fences, road scene detection, transformer, CNN hybrid applications, and object detection, as well as alarms for some examples. At the same time, we are also working to surround smart vehicles with AI sensors both within the vehicle and in its environment connected by Ethernet to drive more complex inferences and support safer, easier driving. Last off, to support the proliferation of more AI applications, we have also launched a Neo platform where we have made available Naren's pre-trained AI models and tool chains for developers and customers to easily create applications based on our solutions. It has been an important gateway for developers to create proof of concepts and take them to mass production with us. So with this, I'm going to bring this presentation to a wrap. For Naren, ARM has been an invaluable partner in enabling the acceleration of smart cameras. And once again, we are honored to jointly present our technologies today. Thank you.
And next, we would like to welcome Mr. C.K. Shi, Senior Manager of Himax, to give a speech entitled Getting Started with Cortex M55, Ethos U55, and CMSIS-NN for Smart Camera Applications.
Hello, everyone. I'm CK from Himax Technologies. I'm glad to have this opportunity to introduce Himax smart camera application using Cortex M55 and Ethos U55. First, I would like to introduce Himax always-on smart camera. We dedicated in ultra-low power solution in always-on application. And our solution include both CMOS image sensor and tiny machine learning processor. We successfully to deploy our solution on laptop application and can fit into narrow border of laptop. And the user scenario is wake-on approach. When the laptop is in standby mode, the smart camera still detecting if their user approaching. If it detects, it will automatically wake up and log in. And walk away lock. When the smart camera detects the user is leaving, it can automatically lock the computer and turn off the screen to save energy. And when the user is not face laptop, the smart camera can detect and try to dim the screen to save the energy. And also privacy awareness. The smart camera can detect if there is other person nearby the laptop and give the user a warning or try and narrow the viewing angle. Because the application is always on, so ultra power is very important. Our solution can do the always on sensing in sub-milliwatt. And always-on smart camera application is everywhere. It could be used in smart home for the surveillance application or smart appliance control. And in notebook, we just mentioned very detailed in the use case. And the smart city, we can in gas meter, water meter, electricity meter, it can auto detect the reader and up to cloud. And in consumer application, for example, in video conference, you can detect which direction the user is. And in smart retail application, and in automotive application, and the smart building application, and the mobile device. For example, in mobile device, we see there are some gesture application and the eye gaze application is discussion. Cortex M55 is a AI-capable Cortex-M processor. The most important is helium vector processing is introduced. It can have up to 8-bit MAC per cycle. It's very useful for tiny machine learning. And ARM Ethos U55 is the first micro MPU for Cortex-M. It can configure 32 or 64, 128, and 256 MAC. And it also has wet decoder and EMA for on-fly wave decompression. It's very useful for model compression. Later in our use case, we also apply the model compression to boost the performance. And based on the data provided by ARM, Ethos U55 compared to the previous Cortex-M processor, there are 480 times machine learning performance boost. And for if we adopt Cortex-M55 and U55 and boost the machine learning performance, our device can run in the machine learning inference as soon as possible, and our device can go to standby mode quickly to save the energy. The deep learning model inference we based on TensorFlow for microcontroller framework. Our model, if the operator supported by Ethos U55, we will use Ethos U55 to accelerate the operation. If it is not supported by Ethos U55, it will fall back to CMSIS-NN library and use the Cortex-M CPU. If it is not still supported by CMSIS-NN, it will fall back to TensorFlow micro reference kernel. And in ARM ecosystem and the TensorFlow provide the tooling for offline optimization. It can do quantization and optimization easier for the developer to developing the model and put on micro MPU. Next, we will see the model development flow for ARM Cortex-M55 and the Ethos U55. First, we will try to explore the model architecture that can fit with our application. Usually, we will try to find some open source model, and the most important thing is the operator in the model. All the operator can support by TensorFlow Lite mode or microcontroller. And then we will see how the model size is. Because we are focused on resource constrained application, usually the memory and the flash is very small. So the model size and the flops of the model is very important for us. Once we have a candidate, we will do the custom train model. For example, we will try to how many channel of the data we needed. For example, using RGB 3 channel or monochrome 1 channel for our application, and how many class of the object we need to classify or detect, or maybe only 1 or 3 or 5 object needed. So we will custom the candidate model to fit our application, and then do the training to see the model accuracy can meet our target or not. So in this stage, we will focus on training to the target accuracy. Once we have the model with our target accuracy, we will do some further optimization. For example, if there are some operator in the model that is not supported by Ethos U55, we may find some modify it to some supported by U55. And because we modify the model itself, so we have to do the training to see if the target accuracy drop or not. Once we have the target accuracy meet, we can do further optimization for our target hardware. In this stage, usually we have pruning or clustering and quantization or training. Pruning, we could make some insignificant weight to be 0, and the clustering, we can cluster the weight into groups. So the compression can make the model smaller. And we can do the quantization over training to make a floating point model to integer model. And if you don't have the training environment, just have a pre-trained model, you can do a post-training quantization. So after that, you will have an integer model. We can use Vela compiler. Vela compiler is a deep learning compiler provided by ARM. Can convert the TensorFlow-like model to ESOS-U 55 command string. And the compiler also will output the statistics such as memory usage, flash usage, and the inference speed estimation. After that, we can deploy the model to the target. We already have some use case that in HIMAX that work on M55 and the U55. Image classification, object detection, and the face detection. Image classification and the object detection are our reference model that user can use that to customize for their target application. And the face detection is one of the example. We modify object detection model to a specific object for the applications. Let's see use case number one, image classification. Based on the model development flow mentioned earlier, we look for some image classification reference model in the internet. And we find that efficient light 0, the number of parameters is 4.7 million. And if the integer 8 model, we can estimate it will occupy 4.7 megabytes on the flash. And because our target device will configure 64 meg at 400 megahertz, so the computation requirement is 407 million meg per inference. We check the data, it should be workable on our target device. So we try to train the efficient net that 0 with ImageNet dataset, and you can see we achieve the type 1 accuracy at 74.01% without compression. Compression means pruning and clustering. And you can see the model size on flash is 4.5 megabytes, and the Vela output the inference time with our configuration, it will about 9 inference per second. So after that, we try to do pruning and clustering. And in the end, we have the number pruning 60% of the parameters to 0, and clustering the weight into 32 groups. So we can see the top 1 accuracy still maintained in 73%. And you can see the model size on flash reduced to 2.23 megabytes. And the inference time has significant improvement to 50.3 inference per second. So based on the observation here, you can see that the pruning and the clustering improve a lot for our system. Originally, you may need to put a 8 megabyte flash on the system to run this model. But after pruning and the clustering, you will only need 4 megabyte flash device on the system. It can save the cost and also improve the inference speed. Use case number 2, object detection. In HIMAX, we create 2 reference models for object detection, and we train on MSCOCO data set. These 2 reference models with larger or small parameters. And we will explain more about pruning and clustering. Before pruning and clustering, we train the model on MSCOCO data set. The AP 50 floating point score is 33.9 and 23.9. And first, we will do the pruning first. So in this example, we pruning 50% of red to be 0. And you can see the AP 50 score still maintain the same scale. And after pruning, we will do clustering, and we do the 128 groups first, and also do the fine tuning. So you can see the scores still maintain in same level, not too much drop. And we can try to do the clustering in less groups. So we try to do the 16 groups clustering. And there are some drop in the AP50 floating point. So finally, we choosing this configuration for do the quantization. So for quantization, we compare two kinds of quantization method. One is quantized aware training, and the other is post-training quantization. Usually, we will see quantized aware training can achieve more higher accuracy compared to post-training quantization, both large model and small model. But for quantized aware training, you have to have the training environment and need to spend more time in the training process. Here we introduce two resolution for the configuration for large model, both for large model and small model. And for some application, you may not need to detect the small object, or the walking distance may shorter. So we can choose smaller resolution. We can continue to lower down the resolution if the requirement can meet. So you can see the combination in the table, different kind of model size, and the input resolution, and apply pruning or quantization. And you can see the AP50 score, and you can see the target model size on flash, and the Vera output the estimation inference time. So based on the table, the user can choose the configuration that can meet their target. And we try to deploy our model on our FPGA because we target on 400 megahertz. So you can see our inference time can up to 20 inference per second, or almost 30 inference per second, based on the model put on flash or internal SRAM. This also shows the benefit for pruning and clustering. After the pruning and clustering, you can see the model size on flash can reduce a lot. So that makes us has a chance to put the model on SRAM to improve the inference time. So it shows again that many configuration combination could be possible, and the user can choose them based on their target. For example, they want to higher accuracy or higher inference rate. Okay, let's check the demo with Himax HM01B0 ultra-low power QVGA color sensor with our object detection model that can detect 80 classes. Here shows the example in indoor scene. You can see the resolution is very low because it only QVGA, and we don't do any image preprocessing. And in the indoor scene, only person available in our office. So you can see the detect distance may be around 7 meters, 7-8 meters. Let's see another demo for outdoor environment. It's a truck, car, and motorbike person. Motorbike and person. Okay, that's it. Use case 2, object detection. Let's see use case 3, face detection. We custom for specific object detection and modify our object detection model to fit using a monochrome image only. Usually face detection, we only need gray level image. And we train on OID human dataset face category. Usually for training machine learning model, we will use other dataset to make it fit our dataset distribution, such as taking picture using HIMAX low power camera. And we only training on one class face. And we can achieve more than 50 inference per second on our FPGA environment. We cooperate with ARM and the TensorFlow ecosystem, and it provides many example and tool set and data set to make easier for the developer to developing a smart camera application with HIMAX and ARM target device. The above is my presentation today. Thank you for your time.
Thank you, CK. Next, we would like to welcome Mr. Ricky Cho, Senior Staff AI Engineer of Tomofun, to give a speech entitled "ARM-Powered AI Dog Camera Protects Your Pet Friends."
Hi, I'm Ricky. It's my honor here today to share the AI-powered AI dog camera, Furbo, and the AI service on Furbo. Now, I'm the Senior Staff AI Engineer in Tomofun. My job is to develop AI service on Furbo with machine learning and deep learning. In this sharing, I will cover 3 things. First, what is Furbo, the AI-powered software-defined AI camera? Then, what is Furbo Dog Nanny, the AI service on Furbo? At the end, why Furbo using ARM? Tomofun is a pet tech company which combines AI and IoT together, founded in Taiwan. Tomofun is also the world's first pet tech startup that implement AIoT product in real world, a worldwide market. Furbo is not only the major hardware product, it's also the world's best threat hosting dog camera. Furbo Dog Nanny is the AI service on Furbo. Furbo is not only the world's first AI pet camera. Furbo can also make dog parent see the dog, talk to the dog, and interact by threat hosting anytime, anywhere. That's why Furbo can always win the top 1 bestseller of pet camera in Amazon platform in various countries for many years. So, what's the secret behind Furbo? First, let's take a look at the Furbo hardware spec. In this slide, we can see the detail of camera spec, two-way audio, connectivity ability. But the most important part is the central processing unit. In Furbo, it's ARM Cortex-A series processor. It's the most critical part to make Furbo as a real software-defined AI camera. I believe AI feature is the key to make Furbo popular and success. Because Furbo leverage lots of AI techniques to serve global customers, Furbo global market share is more than 90%. Global activity user count is more than 800,000 in 133 countries. It also makes Furbo user interact with pet more than 5 million times per day, and more than 50 million pet activity were triggered by verbal AI every day. From those numbers, we can see how dog parents love verbal and verbal AI service. So let's go deeper into verbal AI service. Now we'll come the AI service of verbal dog nanny Joy. Is friendly, caring, smart, and help dog parent to protect pet friend with AI. So what verbal dog nanny can do to help? There are three major features in verbal dog nanny, including color recording, smart alert, and doggy diary. Smart alert will send alert to dog parent when some special event was detected. Let's talk more in later slides. Verbal will also record a 50-second video for the dog to help dog parent review dog activity afterward. Those video, so-called color recording. Color recording will help dog parent never miss important moment for their dog. And since dog may have lots of activity every day, doggy diary will summarize whole day activity to generate the doggy diary. So it's a 60-second video to help dog parent to know more about a dog's day. Here comes some fun and interesting color recording. For those color recording was provided by a verbal user to share more joy with Tomofan and other verbal users. So this is a dog activity color recording. In this color recording, we can see this dog did something bad. Whoa, this dog pulled down the television. What a bad dog. And this one is a barking color recording. I'm not sure if you can hear it barking, but we can still see the dog laugh. Looks very exciting, running and barking. But in the end, it hit the wall. What a cute dog. And this is a running color recording. In this video, we can see the dog is very exciting, jumping up and down and running around quickly. Actually, verbal will get lots of interesting videos like this one. And sometimes dog will do something sticky. This one is the party color recording, but don't worry, the instrument is already masked. In this video, we can see this bad dog pull in our office. In previous color recording video, we already see some of the smart alert. Now let's talk more. Some smart alert will notice dog parent when some special event occurs, including dog activity, dog selfie, person alert, and home emergency. When dog parent receive this alert, they can check by live view or color recording to know more about the situation. All of those alerts were generated automatically by AI. And another kind of alert is barking alert. Barking alert will notice dog parent when dog is barking or continuous barking. As we know, barking is the way dog to communicate with dog parent. Different barking type may have a totally different meaning. Barking alert will also identify different barking type, including howling or crying. So dog parent can know more about the dog's feeling. For example, dog is sad or in fear. As an AI feature, smart alert and color recording are simple and straightforward, but don't underestimate the power of smart alert and color recording. In fact, those factors help dog parent to protect their dog and avoid dog from emergency situation. The website, Verbal Safe Dog Life, shares lots of such stories, and according to the user reporting, more than 2,800 dogs are already saved from deadly situation by Verbal. This is color recording video to show the real case that Verbal really saved dog life. In this video, we can hear the smoking loudly, fire on the kitchen, but the two dogs still don't know what happened, didn't aware the emergency. When dog parents get this home emergency alert in real time, they can notice and watch the color recording video to know what happened, and they can do something to save the dog from the danger. In previous slide, we know how the two AI features, smart alert and color recording, help dog parents to protect pet friends. I would like to go deeper into how we build the AI and for smart alert. Here we have image, audio, and video collected from verbal camera as the input. The output will be the different type of alerts. Now, how to convert business objective into AI, machine learning, or deep learning problem definition? I always like to ask this question to myself. To answer this question, some people may say, trivial, since deep learning can solve everything. Now, when in doubt, let deep learning to solve. So we will have all the data types together as the input and train the end-to-end deep learning model. Well, after joining Trend Micro, people may know the reality. Real-world traffic and data variety is much larger than the data set we can collect. So in this case, end-to-end deep learning may not be a good idea. Actually, Tomofang built Verbal Dog Nanny AI service by separating deep learning model of each data type and alert type. In next slides, I would like to share how we provide different smart alerts from different data. In the image AI, it can provide dog activity, dog selfie, and human alert. Generally, the image AI leverage object detection technology to detect if dog or human is inactive. We study those popular network architecture like YOLO, mobile DAT to build our model architecture and train with verbal data to come out our own deep learning model. Now, there are more than 100 million inferences for dog activity every day. The performance is collected from real-world data in weekly basis. The precision is more than 99% for both dog and human detection. It's a real high achievement because real-world traffic is much more difficult than the academic data set. Audio AI will provide the barking alert, glass breaking alert, and the alert of home emergency. Audio AI leverage audio classification technology to distinct sound in different categories. We study the popular network architecture like CNN40 or VGG-ish to build our own model and train with all the verbal audio data to come out our own deep learning model. The input of audio model is not the raw audio wave signal, but the mass spectrogram. In our experience, after frequency transformation, model will perform better. To reduce the inference cost, audio AI also has a pre-filter on edge device. After pre-filtering on edge, there are still more than 50 million inferences every day, and the real-world performance is also very high. It's more than 95% in precision. It's also a very high achievement. And audio AI is also an example to show how verbal edge device cooperating with cloud to provide better result to dog parent. Audio input will be filtered by edge classification deep learning model to reduce noise and other non-focused audios. Only specific audio will be sent to cloud to do further processing and identify those alerts accurately. So after cloud inference, more accurate notice will be sent to dog parent and the false positive will be reduced. Video AI will provide the alert of a detailed dog activity, include eating, drinking, chew, sniff, running, and party. Video AI leverage object detection, post-extraction, and action recognition technologies to identify what dog doing. The video AI is very complicated, so I will have some detail in next slide. Since the computational cost of this AI is also very high, it's only focused on some more valuable cloud recordings. Now there are more than 50 million inferences every day. And after our hard tuning and the training with more videos provided by our user, the real world performance is now also more than 90% in precision. Now let's go deeper into detail. To identify dog activity, video AI will first decode video into image frames. for those decoded frame, found the dog by object detection, and detect if dog is in motion from all the bounding box found by object detection. Then extract the key point of dog pose by deep learning model. And finally, identify dog action from all the information generated in previous step. So in video AI, lots of deep learning techniques were used. And we see all the AI components are already modularized into different modules instead of an end-to-end model. We believe it will be easier to combine AI components into new data flow to provide new AI features. Besides, Verbal also provides more and more edge AI capability with more powerful ARM ecosystem. The new Verbal is able to do 360-degree panning, tracking the dog automatically, and the patrol to find the dog periodically. To provide those AI features in Edge, the Edge AI leverage object detection, PID control, and even multiple object tracking in Verbal device. All this deep learning computing and complicated AI logic run on device. So those deep learning models need to be compressed and quantized to fit in the computation power and memory limitation of edge device. In order to provide better user experience of AI service to dog parent, Verbal Dog Nanny AI is the combination of edge, cloud, and app. Not only edge and not just cloud, and don't forget the importance of app UI. The cooperation between Verbal edge device and cloud is crucial. Edge play a role as a filter or trigger, so only few data need to upload to cloud for further processing and storage. Cloud play a role to host heavy deep learning model to provide more accurate result. In this cooperation style, it will be easier to make the balance between performance, cost, and user experience. In the last part, I would like to take some time to share why Verbal using ARM solution. In previous sharing, we know Verbal is a complicated embedding system of edge AI. Lots of AI data flow and other logistic process running on Verbal. And ARM ecosystem provide lots of advantage. Here I conclude into 5 categories. First, ARM has the ability to run a fully functional real-time Linux OS. With Linux operating system, we can save lots of effort by leveraging OS features, including time sharing, multitasking, multi-threading, memory allocation, and file system management. And even we can use the system tool. Now, AI and other logistic tasks as submodule or daemon running on Linux and launched by shell script. In AI application, we don't need to handle interrupt or other hard working. Second, ARM processor provide very powerful computing capability. Not only the amazing floating point computing ability, but also the out-of-order execution to speed up AI application very well. Remember, for an AI application, the computational cost is not only the deep learning model itself, but also lots of pre-process and post-process. Image should be cropped or resized to specific size. Audio should be transformed to a spectrogram. Video should be encode and decode. Deep learning results should be normalized, thresholding, or integrate with a certain mechanism. All those tasks will rely on the powerful computing capability of ARM processor. While providing such computing power and well-functional OS, ARM processor is acceptable low cost. Cost is always the most risky factor. So it's a very important point for an edge device with million units sold and reduce the risk in hardware design and manufacture process. For most applications, ARM ecosystem already provide a mature cross-compiler, toolchain, and SDK. In an embedding system, leveraging mature toolchain will dramatically reduce the developing effort and get better computing performance. So it will be easier to build the AI application on top of an ARM ecosystem. And lots of existing SOC solutions already integrated with ARM central processor, image signal processor, and the neural process unit together. While ISP handle image processing, NPU hosts deep learning model, and the ARM processor connect all the workflow and logistics together. Because the architecture is still in ARM ecosystem, it's very easy to switch AI application between different SOC, even just change the compiler option. So when we have a new idea, there is always an existing ARM SOC solution that perfectly hit our scenario. Then AI developer can just focus on AI and deep learning model and get rid of the hardware changing issue. In fact, Ferbo already evolved more than 4 generations. To quickly provide new feature, each generation may use totally different ARM SoC. Even built on different SoC, FDN AI can still provide stable and consistent user experience over those generations. That's because all Ferbo were built on top of ARM ecosystem, and the FDN AI is built on those ARM-based from Ferbo device. All the 5 advantages with ARM ecosystem make Ferbo a real software-defined AI camera. And that's why, in my opinion, Tomofang as a software AI company can build Ferbo device. On the final slide, I would like to share 2 takeaways here. First, ARM ecosystem is the most flexible, powerful, and reasonable solution for software-defined AI camera, just like Ferbo. The flexibility make AI engineer can focus on development of AI application and deep learning model and get rid of hardware limitation. I believe that's why Ferbo is a truly software-defined AI camera and make Tomofang a software AI company to bring joy and innovation to every pet lover in the world. Thank you for your attention with all Tomofang pets. Thank you.
Coming up next is the panel discussion, the highlight of our webinar today. I believe you just excited about the upcoming panel joined by multiple industry elites in the ecosystem as I am. Let me turn it over to our host, Mr. David Shi, FAE Director of ARM.
Hello, everyone. I'm David Shi, FA Director at ARM. Camera is pervasive in the modern days. You can easier find a camera somewhere around you, like street side, parking lots, airport, warehouse, or even at your home. It's estimated that there are around 1 billion cameras already installed in the world in last year, no matter commercial camera or consumer camera. By 2024, there are additional number of billion cameras will be installed, so there is going to be almost 2 billion cameras by the time. That's a lot. Another data point from ITC's forecast, the global video surveillance market size will reach to US $44 billion in 2025 at a CAGR of 13%. That's a fast-growing market, and it's worthwhile to investigate more. Today, I'm pleased to have our VIP partners to join this panel, sharing their view and insight about this interesting topic. Let's welcome Samuel Guo, AVP at Himax, Kevin Xu, Senior Product Manager of Edge Vision Business Center at EddyLink, Evans Yang, EVP at Path Security. Samuel, Kevin, and Evans, could you please briefly introduce your company and yourself? Let's start from Samuel.
Hello, everyone. I'm Samuel. Himax is a Taiwan-based fabless design house company. And the major product including the display driver, TCOM, control IC, and we also provide the CMOS image sensing and the AI processor chips. So in Himax side, we provide the total solution including the CMOS image sensing and the AI processor in the smart camera field. Thanks.
Thank you, Samuel. Kevin.
Hi, everybody. This is Kevin from ADLink. ADLink is a global-based company, and ADLink is focused on the industrial computer. We have different kind of industrial computer for different kind of verticals, such as factory automation, military, and aerospace. And I'm in charge of the machine vision product line in ADLink. So today I would like to introduce you some interesting idea and the applications of the smart camera. Thank you.
Thank you, Kevin. Evans, it's your turn.
Hi, I'm Evans Yang. I am EVP of POP Security. POP Security is a subsidiary of a non-multi-memory IP company, eMemory, and we are developing a series of hardware security solutions, including POP-based root of trust, POP-RT, and POP-based crypto coprocessor, POP-CC, which is based on eMemory's POP and OTP technologies. I'm responsible for the product development and the marketing strategy for POP Security. Thank you.
Okay, thank you, Evans. Samuel, Himax is a leading CMOS sensor and AI vision processor chip company. From a chip vendor's viewpoint, what are the key drivers for smart cameras growth?
Okay, so from our point of view, we saw in this year, we saw has a big a revolution in the smart camera. The change is from the connected device and transmit the capture image data to the cloud, transfer to the autonomous. That means execute the AI capability in the local chip. So we just send out the result, AI result, and we call this is a metadata to the cloud. So it saves the transmission power and protect the person privacy. So that's a very big change in recent years. So in Himax side, we offer the low power CMOS image processor and the low power AI processor combined with our provide the total ecosystem developing system, and we have co-working with some partner with the turnkey total solution also. So we think in recent year more and more use case deployed in the smart camera field.
Okay, thank you, Samuel. Kevin, ADLink is a famous IPC company, and the Edge AI is one of your focuses. Yes. So from a system solutions provider's viewpoint, what drives the growth of smart camera?
Okay, so first, thanks the progress of the processor, I mean the computing power of the processor, and also the progress of the image sensor. Right now, we can have a smaller and the higher performance processor and the image receiver. And meanwhile, because of the AI processor is also getting more and more mature, so we can see a lot of image application can happen in the edge side. Because in the past, we are not able to analyze the image data from the image sensor, but right now with the AI technology, we can do more than before. So from my perspective of view, I think in the future, image sensor together with the processor at the edge will getting more and more popular, which means we can see more and more applications.
Okay, good, thank you. So Evans, please also share your view from security solution provider's viewpoint.
Okay, yeah. Current trend of smart camera development is introducing AI algorithm to help image analysis and recognition for specific purpose. For example, analyzing image data to refine and output more visually appealing image. Or another scenario is using AI algorithm for pattern recognition. When we adopt AI, this AI image algorithm plays the important role for smart camera operation, and it is also the important asset for camera product developer. Therefore, it needs to be properly protected to ensure the core competence of smart camera for market competition.
Okay, good point. Thank you, Evans. Okay, my next question is about the challenge. So please share what the main challenge you face when you develop your products and how an IP or an solution can help you to address those challenges. Samuel, please share your view.
Okay. So we sold a lot of the smart camera application and more request the low power. That means that is a battery powered smart camera, because the benefit of battery powered smart camera is easy installation and easy maintenance. So such kind of the requirement. So during our design, our chip architecture, we need to consider the power consumption. And we need to consider within such kind of the power consumption constraint, we must provide significant enough the computing power to the application. So I mean the key challenge is the trade-off between the computing power and the power consumption constraint. So to overcome such kind of the constraint, we need to have the powerful processor within some active power constraint, so we can execute the model in a very short time, and then we move to the standby mode. Such kind of the design challenge.
Okay. Yeah, Samuel, yeah, good to know that the combination of Cortex M55 and U55 can meet both, the computing power performance requirement as well as low power consumption requirement. Good to know. Thank you for sharing. Yeah, I think time to market is very important to IoT products success. ARM launched ARM Virtual Highway in October last year, and further announced a broader range of virtual development opportunities for ARM processors and the third-party developed boards and real-world devices in April. It provides application developers and the SOC designers a visible way to build a test software before real silicon and hardware board available. So Samuel, I know before your edge perception chip tape out, you ever work with third-party software partners using ARM virtual hardware model to develop and verify the application software in early stage, even without real hardware platform ready. So what's your feedback from you and your third-party partners on ARM virtual platform?
Okay, I think this is a very good question, and we are very excited. We adopt ARM's FVH virtual platform. So in our working with our partner experience, I think before if we have the FVH platform, and then we must have the chip and the board, and let our customer to deploy their model on our chip. But with ARM's FVH platform, we can provide such kind of the platform to let our partner, our customer, to deploy their model to check the inference time and to check the power consumption in advance. So after our chip and the board are ready, and then our customer and our partner will be porting their model to our system very soon. I think that's very good platform for tiny ML and the micro NPU system.
Yeah, good. That's good. Yeah, thank you, Samuel. Yeah, good to know. By using virtual hardware, your third-party software partners, and you can develop hardware and software simultaneously. Yeah, you don't need to wait for each other. That's a good news. Thank you, Samuel. So Kevin, yeah, please also talk about the challenge in developing camera devices and why you choose ARM solution for your camera devices.
Okay, our customers put the camera at the edge side. That could be the factory or some harsh environment, which means we need to take the balance between the size and the heat. And we also need the product to be reliable and rugged, such as IP protection. So by using ARM processor, we can get the higher computing power, but with lower heat. So that is a huge benefit for our to design a total system.
Thank you, Kevin. Yeah, I know AD-Link is aggressively involving in ARM system-ready collaboration with ARM, and you got a single-board computer, SMART. It already passed a system-ready IR certification. So who AD-Linker consider to join Project Cassini on more product lines, such as AI smart camera, to have these extra security layers?
Yes, sure. I think this is very crucial and important for both of us and our customer. So yes, we will do that.
Okay, thank you, Kevin. Yeah, looking forward to the further collaboration on System Ready. Thank you. System Ready reduce fragmentation in the ecosystems through a standard approach in order to scale development by becoming the platform of choice of ODM and software develop. It gives confidence that operating system and subsequent layers of software just work. So Evans, please also talk about the challenge from your observation and where do you collaborate with ARM in your product?
Yeah, sure, no problem. Yeah, we have just like we have mentioned, the security need for smart camera product. The smart camera product for pop security point of view, we took at two main aspects. The first one is to help smart camera product manufacturer protect the product design know-how. And second is to enhance the security of connectivity application and protect user privacy. And without protection, without this protection, customer application may face considerable loss. Imagine a hacker attacking smart camera used for home security monitoring to detect whether there are intruder or fire alarm. Once attacked, the home security system may fail. And the other scenario is if a hacker take control of the smart camera, they can obtain the video content and cause the personal privacy issue. Since we are working with ARM, we currently collaborate with Cortex M series, such as Cortex M33, Cortex M55, and also Cortex A series, so that customer can be assured that no matter which CPU core they choose, they can adapt with our security IP to enhance chip security. And ARM has a well-developed CPU ecosystem and implement a credible security assessment or PSA certified. While Pop Security has a complete hardware root of trust IP in the market, our partnership can provide smart camera clients with security protection and enable smart camera to fully perform the function and the advantage of the product.
Okay, thank you, Evans. Yeah, no doubt, security is critical to connected cameras. especially when the cameras are used in private place, like indoor security system, or in some scenarios, the camera capturing sensitivity image, like factory automation system. The data and code protection becomes a basic requirement. Samuel, please talk about the security functions in your products and why you need those security functions.
Okay, so in the smart camera application, this is a vision-based application. So security and privacy is most important for users' requirement. So most of the security feature, for example, security boot, OTA, or security TOS, such kind of secure feature are required by our customer. So in our system, from the initial design step, we consider to support the security boot, OTA, and the TOS. So we need to using for example, using some TRNG generator, and we need some kind of unique key of our chip, and we need a crypto engine to boost our security execution. Or such kind of the hardware requirement and the related software requirement is our consideration in our design initial stage. So we offer the solution including the security boot and including the TLS and the OTA, and we also support the ARM's trust zone software stack, and we will pass the PSA the standard certification. I think such kind of the public and the standardized security requirement is our customer need.
Okay, thank you, Samuel, for your sharing. Yeah, AD-Link Smart Single Computer Board has passed not only system ready, but also PSA certification. So Kevin, so please share your view on edge device security and how do you implement security functions in your product?
Okay, for our customers' application, of course, the security is also very important. For example, sometimes customers need to remote control the devices. Or for the AI vision applications, sometimes such customers need to upgrade or upload the new AI models. So when they doing this, the security function become very important. Right now, we leverage the solution from ARM's ecosystem to help our customer to doing this.
Okay.
Thank you.
Thank you, Kevin. Okay, so Evans, PUB Security is a security-focused company. So please introduce your security solutions for IoT products.
Yeah, sure, no problem. IoT security major focus on three main points. We need to protect data in use. We need to protect data in transit, and we need to protect data at rest. But in the past, most of security topic major focus on the software layer and the application layer. Yeah. The programmability of software give more flexibility for product development and product application. But however, it is a double-edged sword. It also gives the attacker a chance to modify an attack if without solid authentication for software modification. In real life, how to make sure the software and the application you are using are secure. And to resolve this issue, we need a immutable hardware root of trust from the hardware side. So our innovation is to use unique physical characteristics of each chip, say chip fingerprint as the root of trust. And the chip fingerprint is the most fundamental key that can only be accessed by the chip itself and cannot be copied or stolen. So based on this, we can develop the security function required by the overall system, such as deriving more key, encrypting OTP to keep key storage safer, and realize secure boot and so on. So and another advantage of using PUF is we can avoid large-scale cracking since each chip has its own unique key. And our IP design is all compliant with PSA level 2 and validated by the third party. And applying for PSA certification help us build customer trust. It's just like if you're concerned about the food safety, when you buy food, you will choose the food with safety certification. So when deploying tens of thousands of IoT products into the market, it is very important to have a unified framework of security standard. So with PSA certification, it helps customer product security and also enhance more business opportunities.
Okay, thank you for your sharing. Yeah, very useful. Okay, security is in ARM's DNA. We create and provided security solutions from different aspects. TrustZone provides hardware-enforced isolation between secure and non-secure processing environments. ARM CCA introduced in ARM v9 architecture built on the strong security foundations of TrustZone and introduced the concept of dynamically created ROM, which reduce the volume of software that must be trusted and attach service for hacker and the opportunity for customer data breach. PSA is a security framework. It was created to help ensure security in design into a device from the ground up, all the way from analyze, architect, implement, and certify. PASIC is an open API for cross-platform security service. All those security solutions are widely applied in various IoT devices. Smart camera deployed in many places like parking lot, home, factory, etc. Let's talk about smart cameras use case. So Samuel, what is most interesting computer vision use case you ever see?
Okay. There are many use cases using in the IoT and smart applications. Here, I'm very excited to share with our recently we work with a brand name notebook partner. We announced a new smart camera application in the laptop. So in this application, it's very interesting. This application, they can detect a person or not person. So using such kind of AI mechanism, we can achieve the smart application to detect person, then automatic login to notebook system using Windows Hello OS features. And we also can detect the second person for the picking applications. So such kind of AI value-added application will let a user has a more fantastic experience.
Okay, yeah, good to know. HiMax, enable notebook with more intelligence. Yeah, thank you, Samuel. So, Kevin, do you see any, interesting use case in smart camera applications?
Sure. I can share some interesting applications. The first that I want to share is from the cookie factory. I think everybody loves cookie, but you may know in the future the cookie you eat may be selected by the AI cameras. Right now, the cookie makers rely on the people to do the inspection, to pick up the broken cookie, the bad cookies. And this kind of operation needs a lot of people effort and also introduce high cost. But right now, we are able using the AI camera to identify the bad cookies and pick it up. So in the future, the cookie you eat will be qualified by the AI camera. The second application I want to share is people start to install the AI camera on some heavy machine, such as the mining truck or the forklift. That would be very easy to understand when the heavy machine are working and somebody is too close. That would be some tragedy happens. So to avoid this happen, people right now start to using the AI camera to detect whether people is getting too close. If somebody is too close to the heavy machine, then the system will give the alert to the driver or stop the vehicles. So by using this kind of AI camera, we can help people to be more safe.
Okay. Yeah. Very interesting use case. Yeah. It really, make manufacturing more efficiently. Yes. And the second example, it does make human more in a more safe environment.
Yes.
Yeah, it's very useful. Thank you. Yeah, I think Taiwan has strong electronic, industrial, and semiconductor supply chain. So, what is Taiwan's strength in smart camera development? Where is the opportunities for Taiwan companies in this segment? So, Samuel, could you please share your observation first?
Sure. So we saw Taiwan has a very complete ecosystem from the chip manufacturer, IC design house, to the system manufacturer, OEM, ODM, and backend. So how the complete ecosystem are built in Taiwan. So not only the ecosystem, we saw Taiwan based company has a complete ICT manufacturer design flow. So they can has a very solid design qualification stage for the manufacturer. So for the smart camera application, we saw the smart camera application from the small volume, very diverse IoT application, and move to the middle volume smart application. And then currently such kind of design into the notebook application. This is a very big volume application. So I think Taiwan-based company, we are very familiar with such kind of ICT design flow, and we have a solid qualification manufacturer. And I think smart camera application is very good for Taiwan-based company to keep such kind of the momentum to have the production and the benefit for the business.
Okay, thank you, Samuel. So Kevin, please also share your viewpoint.
Okay, I think one very good feature Taiwan has is we have entire or comprehensive supply chain from the building block chip level up to the entire vision system or total smart camera system. Okay, and thanks to the increasing of the computing power and the AI, right now we are able to using the low power consumption processor to analyze the image data at the edge side, which helps us to do a lot of things we cannot do before. For example, we can do the smart houses, smart building, smart agriculture, and more. We can do more product inspection or people safety monitoring in the factory. So I think right now we have the advantage, and we can focus on many kind of new applications. Thank you.
Thank you, Kevin. So Evans, please also share your viewpoint.
Okay. Just like Kevin mentioned, Taiwan is the biggest advantage is the ecosystem, which include product design, manufacturing, and the application. So in here we can work together quickly to accelerate the product time to market and creating multi-win. I mean, a win-win-win for the entire supply chain and also the users. Thank you.
Okay. Thank you, Evans. Okay, let's move on to my last question. Samuel, Kevin, and Evans. I think you can either answer, what is the key technology or market trend you see in smart camera, or you can just, summarize your talking point for today. Yeah, let's start from Samuel.
Okay, so from our observation, we saw in recent years the smart camera computing is moved from the from cloud to the edge. So such kind of the transition, we saw it will help to the balance, the smart camera balance. So we saw this is a very good chance to in the smart camera field. So combined with the Taiwan's manufacturing capability and the design capability and the trend of smart camera transition, I think that's very good opportunity to in the smart camera field.
Thank you. Thank you, Samuel. Okay, Kevin, please.
Okay, I think the AIoT will be more and more popular, which means the sensor will be more and more popular. However, the image sensor could be the most important one because people say one picture can tell thousands of words. And right now, because of the AI and the higher computing processor, we are able to do a lot of analysis which we cannot do before at the edge side, and which means we can create more and more applications. So I think the combination of the image sensor and the processor will be the main trend or the mainstream we can focus in the future. Thank you.
Thank you, Kevin. Evans, please also share your view.
Okay. Yeah. I think the importance of security in smart camera development cannot be overlooked. Here I share some of my our observation. Two aspects for the IoT security development are worth noting. Yeah, the first one is about the smart camera product itself, and we need to ensure the design know-how and the algorithm of the smart camera can be effectively protected. Only when the product is protected, the business can keep growing. And the second one is about the security demand of IoT application. Yeah, we need to ensure users' data and the privacy when they are using the IoT smart camera application. The data and the privacy are properly protected. So PUF Security and ARM's joint security solution ensures smart camera product meets the above security requirements. Thank you.
Okay, thank you, Evans. Smart camera transformation is taking place, and it's driven by three key trends: endpoint AI machine learning, security, and the cloud native. ARM provides complete smart camera solutions, including high-performance CPU, NPU, ISP for efficient computing, PSA, PASIC for security, system-ready and ARM virtual hardware to speed up the deployment of new platforms. ARM partners are able to focus more on their innovation and the differentiation based on the foundation we built. Today, thanks for Samuel, Kevin, and Evan's participation and share lots of insight. Let's work together to enable more possibilities in smart camera industry, bring more value to the users. I hope the best vision use case can run on ARM and the future can be built on ARM together with our ecosystem partner, Himax, AD-Link, and the PUF Security, and more. Thank you. Bye-bye.
Thank you.
Thank you. Bye-bye.